Welcome everyone to day 3 of the AWS Certified Solution Architect Associate 2022 Bootcamp. And again, this is a free full AWS course. And today we're going to cover again the AWS Certified Solution Architect Associate curriculum. So hope you've all had some fun in the previous few days. Want to go over a few things, a few housekeeping things before we begin, and then we'll take it from there. So hope everybody's enjoyed the first and second day of the AWS Certified Solution Architect Associate 2022 course. If you've missed day 1 or day 2, guess what? All you need to do is as follows. Go back and watch day 1 or day 2, and feel free to send it to somebody else that you know so they can get the training too. Again, it's completely free. Along with this free AWS Certified Solution Architect Associate 2022 course, the link in the description is below. There is a completely free AWS Certified Solution Architect Associate and Professional ebook, and it's completely free. It's going to help you with the exam and help you get your first cloud architect job or cloud engineer job or any cloud job that you want. So please go download that. Now, there's also special lab videos. We're covering this live with the content, how things work, why you use them as an architecture perspective, but many of you might not do cloud admin jobs or cloud engineering jobs, and you're going to have to get hands-on for those jobs. So for those jobs, we've got a free lab access course for you. Again, it's free. The link is in the description below, so please go download that. For any of you that are actually interested in getting your first cloud architect job, temporarily for about 2 more days, we have a 30% sale on everything. As those of you that know us know that every single day, at least 1 or 2 of our students gets cloud hired. And because of this, we've taken a program that I've done for 20 years to help people get their first tech jobs, took it online, and literally speaking, every single day, I've got a student that gets graduates, regardless of their background, they're all getting cloud hired. So if you'd like to train with us, 30% off right now until the 15th, please take advantage of this. So many people have in the last 24 hours, and we can't wait to get them trained and, of course, cloud hired. So kind of know about these things that we're going to do. And Chris, aren't we premiering a security video tomorrow, which is going to be lots of fun? And if so, what time is that?
I don't remember the exact time, but I'm putting the link in the chat box.
Okay, tomorrow we're going to premiere a video with you. I spoke with, an incredible blockchain and incredible security professional that's been doing high-end security stuff for 20 some years. He and I go way back from similar backgrounds, and it's going to be a really interesting discussion on building multi-cloud, high availability, high performance security architectures. We'll talk about ethical hacking, which is always kind of fun, securing systems and blockchain. And we'll be there online with you live so you can ask some questions and sign up. It's going to be lots and lots of fun. But let's get back to the AWS Certified Solution Architect Associate 2022, a complete, free, full AWS course, and let's get it. And if we can kick it off while we're waiting for YouTube to notify everybody to join the class with a hashtag cloud hired, that's music to my ears. If you're joining us for the first time and you're not a subscriber, please subscribe and hit the bell so you get informed of new things. And, vote for our next boot camp. Do you want it to be a Google Professional Cloud Architect or the AWS Azure Expert? Vote. And guess what? We got another one coming for you free very soon. So keep that in the back of your mind. Everything we can do out there to get you cloud hired. So I'm starting to see the cloud hireds coming in. I'm starting to look. I see a G Singh. I did my CCIE with a Gurinder Singh many years ago. And boy, we were really close friends. So every time I see a G and a Singh, that is me thinking of my buddy Gurinder. So Sajith, great to see you. Chow, cloud hired for everyone. Yes. Tunde, cloud hired. I hope you're the Tunde I just spoke to an hour ago. Charles, cloud hired. AJ, cloud hired. Now, this is we're talking about Vikas, thank Blyzy, Glame. Now, Simon, cloud hired. Now, this is music to my ears. In Texas. I love that. More in Texas. And actually, while we're all getting joined, also tell me where you're from. Today, I'm in Port St. Lucie, Florida. I know Chris is in St. Petersburg, Florida. I know Leo over here is in Brazil. I believe Chow is over there in Dallas somewhere. I know Mufaz is over there in Nigeria. I know Tom is in the Netherlands. Nurse as a service. Nurse as a service. Let me tell you one thing. I am thrilled to have you here. I was a nurse before I was a nurse practitioner, and healthcare and tech go together like a glove. The therapeutic communication, all those skills that we have in healthcare make us phenomenal architects. And I've been training medical professionals forever. Gurinder, New York City. I wonder if you're my friend Gurinder from 20 years ago. Mr. Businessman. AJ in Nigeria. Wow. Loving this. All over the world. Atlanta, Texas, Bangalore, India. Haven't been there in a while. Need to get there. London. I'm loving this. UK, Kansas City. Abigail's in Asheville. She's all over the place. And Montreal, Canada. Wow. Nurse as a Service, Camille. Fantastic. We are thrilled to see you here. Thrilled to see you there. Art Anthem, Sony. Wow, this is great. And loving this. Okay, so we're all over the place, and this is really great. There's nothing better than getting the world's best and brightest from all over the world, collaborating and working together for a common goal. I absolutely love this. And I haven't been to Beirut, Lebanon in a while, but let me tell you, I loved it the last time I was there. It was a really great experience. And Liverpool. So let's hit the like, comment, subscribe, and let's get into the content today, because today we're going to talk about basic networking. Now, if there's anything I've ever loved in my life, it is networking. In fact, my networking career has been so old that my Cisco certified internet expert number is actually 7417, back when it was a 2-day test. So when we go through this, the assumption is you already know some networking. Now, if we find out, for example, that there are certain things that you don't need now, and we need to do a extra class, we'll probably do it. So let's see how things go. Let's see how you all go. Let's see what you need. And whatever you need, we'll get you there. To begin, I want to talk about the OSI model, or the Open Systems Interconnect model, when we're going to talk networking. And here's the reason why. Did we discuss high availability networking design yesterday, by the way? Okay, so let's going back to the basic networking interview. There's a model called the Open Systems Interconnect model. And in the Open Systems Interconnect model, it's how we networking people understand the network. And realistically speaking, there's about 7 layers. Now, we networking people only use 4 layers of it, but there's technically 7 layers of this model. And I want you all to understand what they actually are. So let's talk about what they are. And at the very essence, we've got when we deal with networking, we have a lot of things we need to deal with. So the first thing we need to deal with is the wire. So, many of you use Wi-Fi in your house, Wi-Fi on your mobile phones. And I'm going to tell you this right now. If it matters, it's wired. I'll say this again. If it matters, it's wired. Wireless is not reliable forms of communication. Wired is. So your physical layer will be your wire. Now, if we were dealing with wireless, the physical layer would be the wavelength. But the physical layer is the wire. So what goes on a wire? Well, electrons. What else goes on a wire? Photons, if it's fiber optic. So we're going to have layer 1, or the physical layer. This is your wire. Now, next up the link is the data link layer, which is layer 2. Now, this is a physical device. So if you notice, you go to your computer, and your computer has an Ethernet cord where you plug that cable to. That Ethernet card is operating at the data link layer. It has a hard-coded address to it, a layer 2 address called a MAC address. Of course, if we were working in the old WAN days, we'd have things like DELCs, which could be link layer addresses, etc. But the layer 2, as we're dealing with Ethernet, is a MAC address. So if any of you were on a Windows computer and you went to a command prompt and you typed ipconfig/all, you'll see all the IP interfaces, and you'll see the hard-coded MAC address of all your systems. Now, guess what? If you're in a Unix or a Linux machine or a Mac, if you typed ifconfig, it's going to give you the same information. So physical layer wire, data link layer card. Now, at layer 2, we send something called a frame. Now, the next layer up is the network layer, and the network layer is where the cool communication happens. This is where logical addressing, such as an IP address, would be put. Or in the good old days, AppleTalk addresses, IPX addresses, and all those other kind of cool stuff. That's what we're kind of talking about. So kind of keep that in the back of your mind. So layer 1, wire. Layer 2, data link, card, MAC address. Layer 3, IP address, logical addresses. Layer 3, we send something called packets. Now, somewhere along the line, if I want to send information to someone, so if I want to send information to Cecil that's over here, or I want to send information to Pat, I've got to control how the connection is sent. So that's where we get to this transport layer. And the transport layer determines the communications protocol that's going to be used. So is it something where we need to guarantee reliability from point A to point B, in which case we use TCP? Or do we need to guarantee real-time traffic, in which case we use UDP? Wait, maybe we got to troubleshoot the network and we want to allow another layer 4 protocol such as ICMP. So layer 1, wire. Layer 2, card. Layer 3, IP address or packets. Layer 4, transport layer, we're talking about segments. Now, for a networking professional like me, that's it. Physical layer, wire, data link layer, card, network layer, IP address, transport layer, TCP, UDP, ICMP. So for we networking people, that's it. Now, there are more layers, though. The next layer up is the session layer, and really that's just controlling the connection of what's going on. There's a presentation layer, which takes all this information and presents it to the application layer where the users use their stuff, and it then brings it down to the transport layer. That's called the presentation layer. Things like encryption happen to this layer, typically speaking. And then the application layer. If you can click it with your mouse, it's an application layer protocol. So things like a web page, DNS, SSH, these are full applications. I'm going to do it one more time. Layer 1 wire, layer 2 card, layer 3 IP address, layer 4 TCP, UDP, ICMP, layer 5 session, whatever. Layer 6 presentation, does your encryption. Layer 7, it's your browser Safari, your Internet Explorer, your Google Chrome, the cool thing that you do on your iPhone to check your stocks or check your email, whatever. They're all application layer protocols. So now you know the basics of the 7-layer OSI model. Now, when it comes to your virtual private data center or your VPC, your virtual private cloud, we have to remember this. Every system that you want to communicate on the network needs an IP address. Now, more than that, every person on the network that wants to talk to each other needs a unique IP address. So if Abigail's over there in North Carolina with an IP address, and I'm over here in Florida with the same IP address, we got a problem. The traffic destined for me may go to Abigail, and the traffic destined for Abigail may go to me. In fact, chances are, if it's closer to Abigail, it's going to Abigail. And if it's closer to me, it's going to me. So, that's what we really need to talk about. So keep that in the back of your mind. So every device needs a unique IP address, completely unique IP address. So think about getting mail, because it's kind of the same way. Kind of getting mail. On the letter, you put Cindy the cat. And Cindy the cat's address is 1234 Main Street. And Cindy is in Palm Beach Gardens, Florida, 33418. So, that's Cindy's address. Here's the thing. Cindy could have a friend, Noni, that's sitting there over in Asheville, North Carolina, which is Abigail's beautiful cat. And they could both live on 123 Main Street. It's just that, Cindy lives in Palm Beach Gardens, 33418, and Abigail's cat that lives with Noni, who lives on 123 Main Street, may have a zip code that's something different. So it has to be unique. So we're going to be talking about that as we go through. Now it's just like a mail. It's just like a letter. You've got to have a unique address to identify her. Imagine walking into a room. Let's say you're Greek like me, And let's say your father's name is Nick, and I have 10, and he has 10 brothers. All their kids are going to be, let's say all of our kids will be naming our kids Greek. So you can walk into a room and everybody's all got the same name. So when I go to my village in Greece and I say, hi, Nick, I get, hi, 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 hi. Well, obviously it's a problem. So I say, Nick G, Nick U, Nick S, Nick this one. So I've got to do it. So you've got to do the same thing when we're talking about stuff. So make sure every address is unique. Now there's going to be a lot of techniques that go into IP addressing, and it's very critical. So unless you are an IP networking expert, find yourself a professional to actually do the IP addresses. Now, when you address your VPC, the good news is it's pretty standard. Your VPC is just a virtual private data center, so all the same rules, almost all the same rules apply in the same place. So we've got a couple of kinds of IP addresses. Now, here's the reality. We ran out of IP addresses decades ago. And because we ran out of IP addresses a long time ago, the Internet Engineering Task Force, which you can find IETF.org, and I strongly recommend you remember this website, IETF, or Internet Engineering Task Force.org. And on there, they have what's called a request for comments. You know what a request for comments is? The actual specification, and I've worked on several of these. So if you want to know how anything works in the perfect depth, you go to the Internet Engineering Task Force page. There's a specification that's called an RFC, and you can read how everything works. And all manufacturers that use open standards protocols have to read this, and they make their content match this. So you want to be great? Read your RFCs. Want to know how your CCIEs learn the protocols? We read the RFCs. So I'm giving you those kind of advice. So in Internet Engineering Task Force, RFC 1918, they said, hey, wait, we don't have enough public addresses, so let's come up with some private addresses that we can use internally to our networks and only use public addresses on the stuff that needs to be reachable. Really smart idea these guys have. And girls. And they came up with 3 networks, and they reserved them. The first network is the 10.0.0.0/8, a huge, giant Class B address, which gives you about 16 million IP addresses. So there's that. They've also said we can use the 172.16.0.0/12. And that gives us a whole lot of IP addresses. It gives us all the way from 172.16.0.0 all the way to 172.31.0.0/16. So kind of keep that in the back of your mind. And we also have this, the 192.168.0.0/16. So we've got a massive number of private addresses that we can use, but they're not globally routable. So we can't use these on the internet. We may not be able to use these when connecting to partner organizations. And if we do, we're going to need a public IP address, or we're going to need to translate the address into a public address, and we'll talk about that later. Now, I almost don't even like discussing this, but I'm going to do it anyway. There's something called IP address classes. And 100 million years ago, when the dinosaurs roamed the earth and I went involved in networking, they used to have something called Class A addresses, Class B addresses, Class C addresses, and Class D addresses. And what that really was is we came up with ridiculous, useless boundaries that a Class A address began anywhere from 1.0.0.0, and it could go all the way to 126.255.255.255, and they were all /8s. And basically speaking, a /8 was 16,777,000 plus IP addresses. We then came up with Class B addresses, which were in the range of 128.0.0.0 all the way to 191.255.255.255.255. And basically, this gave us a whole bunch of subnets that were basically 65,000 addresses each. Then they gave us a bunch of Class C addresses, which were always a /24 and the subnet mask, and that meant they gave us about 254 hosts on a subnet. And then we had Class D addresses, which actually are real, which I spent half of my career working with, which were used for IP multicast. And that's in the 224.0.0.0 range to the 239.255.255. And there's another range called Class E, which is experimental. Nobody uses it, so let's not waste our time worrying about it. Now, This is 100 million years ago when the dinosaurs roamed the earth and when I started to go into networking. So around the time I went into networking, the Internet Engineering Task Force said, hey, wait, guess what? These IP classes don't work. We're out of IP addresses. We need something else. So the whole point of this is we decided to say IP address classes, completely worthless. And we came up with something called classless interdomain routing. And what is classless interdomain routing? It basically means we can subnet or supernet or go up and down around the range, and we don't use IP address classes anymore. So modern times equal classless addresses. So how does this work? We basically subnet our systems down. Now, what's going on? And AWS will allow classless interdomain routing, as did Cisco and Juniper. And it all started about 30 years ago when everything was changed to classless interdomain routing. But we know the good news is when we're dealing with AWS, they're actually allowing normal stuff that actually works in lots of environment, which was classless routing. So what's going to happen is everything will be subnetted down, and the routers are going to build a map of the network. And we'll talk, maybe I'll actually whiteboard that out for you guys to show you what it's like. But basically what's going to happen is the routers will make up a list. They'll build a map of subnets and they'll know how to send their data. But in any case, what happens is when you're on the cloud, you'll be given an IP address block. And from there, you will subnet it down. So I'm trying to think about this. We'll briefly talk about subnetting. And something tells me if we run into trouble here where people are struggling on the subnetting, what we'll do is we will do a bonus subnetting workshop. So let's just bear with me. Let's see how things go. So realistically speaking, if you are given a class A address, like there's a 10.0.0.0/8, what you have to understand is, as it stands, that's one network. Now, let's say you've got a router or a computer that has two network cards. Did you know that each network card has to be on a different IP network or subnet? So for example, if you put 10.0.0.1/8 on one Ethernet card, you would need another network or another subnet on the other Ethernet card. Now, if you put that 10.0.0.0/8 on this one card, what would happen is you'd actually be wasting 16,777,000 email addresses, which is not good. So what we do as architects, as networking people, as professionals, is we take the big IP address block and we chop it down into multiple blocks into things that we need to do. So for an example of what this could look like, it looks like this as follows. Let's say we are given a Class C address of a 192.168.1.0. Well, we pop that on an address, and guess what? We can put 254 hosts on it, and it's perfect. But what if we didn't need 254 hosts? What if we needed 10 hosts per subnet? Then maybe we use something smaller. I'm going to tell you this right now in architecture. WAN links get a /30. LAN links get a /24. WAN links /30. Why? A /30 gives you two usable addresses. How many addresses do I need on both sides of a wire? One on one side, one on the other side. So WAN links get a /30. Here's a secret. LAN links almost always get a /24. And here's the reason why. If you think you're going to need 20 servers, trust me, you'll need 200. And we can't really get much above 250 servers in a subnet. And here's why: all the servers do broadcast. ARP, who has the MAC address for this? Who has this thing? Broadcast. And all the computers are broadcasting. Anyway, too much broadcast is overhead on your systems, and that's what's going on. So kind of keep that in the back of your mind. And for those of you that are not here, we have a complete, full, and free CCNA course. That is the only one we recommend for learning this. If you don't take our CCNR course, we recommend going to Global Knowledge, which is about $5,000 for the week, or going to the Cisco Academy. I did teach engineers while I was at Cisco, so we recommend that for people that desire CCNA training. And ours is completely free. If you were at Cisco and you took the course when I would be teaching it, it would be $4,000 to $5,000 for the week. I taught it completely free. It's attached to our channel. So if you're learning or struggling with networking, we strongly recommend that. But as you can see, what we're doing here right now is you can see we've got this 192.168.1.0, and we broke it down into a 192.168.1.0/28, which gives us all the way 192.168.1.1 as a usable address, all the way to 192.168.1.14 as a usable address. 192.168.1.15 will be the broadcast, and the 192.168.1.0 will be the network. And we can do the same thing for the next subnet and the same thing for the next subnet. Now, I have a sneaky suspicion many of you guys are going to want a subnetting workshop, and if that's the case, we'll do it. How much sort of, if that's the case, that's what we'll do it. So I want you to understand one other thing. AWS does networking funny. So when you're outside of the cloud and you're in any data center anywhere in the world, the formula to determine how many hosts per second is 2 times the number of host bits minus 2. So normally speaking, if we have a 192.168.1.0 with a /28, which is going to be a 255.255.255.240, normally speaking, we would have 16 total addresses, meaning the 192.168.1.0 would be the network, and the 192.168.1.15 would be the broadcast. And every address in between would be usable. The next subnet would begin at 192.168.1.16. It would end as the broadcast address at 192.168.1.31, and the usable addresses would be in between that range. So if you guys are struggling with subnetting and we're done, you'll put in a request for a subnetting workshop and we'll make that happen. How do you put in a request for a subnetting workshop? Well, you pop it in the chat box. And if we get enough of them, my team will try and find a time to do it. So let's now talk about the exact opposite of subnetting, which is route summarization. So here's what we need to really talk about over here. When we're talking about route summarization, we're going in the opposite direction. So we can take multiple small subnets and pop it into one big subnet. So why would we do that? Well, let's give you an example. Let's say you're dealing with an enterprise that has 40,000 subnets in the routing table. Very common thing. So we've got 40,000 subnets, right? Now, when you send your data to AWS or your routing information to AWS via BGP, they take 100 routes. If you've got 40,000 subnets, you can't take them. So you need to be able to summarize your routes so you can give partial routing information to the to the next provider. So that's what supernetting is for. And supernetting is the exact opposite of subnetting. It's really about making a big network. So here's what that'll look like. So if we have multiple subnets, we can aggregate them together. And we network engineers do this every single day. And we have to. So imagine you've got 1,000 routes. And you want your cloud to be able to reach your data center, which you do. If the cloud provider doesn't have the routing information from you, they can't reach you. So let's briefly talk about IPv6 addresses. And what is an IPv6 address? It's a new form of address that was generated by who else? The Internet Engineering Task Force, IETF.org. And what happened is the IP addressing scheme is a 32-bit binary address. And binary is either 0 or 1. By comparison, IPv6 is a 128-bit hexadecimal address. So, want to know how many addresses you've got in IPv4? 2 to the 32nd power. Want to know how many IP addresses you have in hex? Well, hex begins at 0 and goes to F, which is 15. So we technically have 16 addresses. So 16 to the 128th power, that's what we've got in terms of hexadecimal IPv6 addresses. So infinitely more space. Now, IPv6 addresses are typically used by your mobile phones, not that much else yet. but all interfaces in AWS are automatically getting assigned an IPv6 address. So, we talked about some basic intro to networking things, but, I'm not 100% sure that everybody has a basic networking foundation. So I want to do two things. One is we did a subnetting workshop, and I'm going to ask somebody from my team to actually post that as some of the previous subnetting workshops. Okay, great. My team already did it. I'm super excited about that. So fantastic. And we'll schedule another subnetting workshop and we'll work you through it because, it's very important to get this. You don't get this networking thing, you don't have anything. So we'll schedule a subnetting workshop. It looks like enough people want us to do it. We don't mind doing it. We love training the world. So we'll schedule a subnetting workshop. And in the meantime, you can look at what we've done so far. So I'm sure there's some questions. Chris, if you want to bring in the questions, we'll try and address some questions for a few minutes before we go on to anything else. Chris, what questions do we have?
You give me a second. You just asked for them, so no. You got to give me a few seconds at least.
See, it's not easy to coordinate things over large distances when people can't even see each other. Do I have a table showing IP address classes? I do, but here's the thing. There is no such thing as IP address classes in today's world. And if you try and do things via IP classes, they're not. So about 30 years ago on the Cisco routers, we used to put IP classless. So class A's go from 0 to 127. But I don't want you to get stuck on this. I just wanted you to understand that there used to be classes of IP addresses, and now there are not. You want a visual for what it looks like, sure, that's fine, it's no big deal. Visually speaking, it looks like this. But these are your class A addresses, these are your class B's, and these are your class C's. And class D you'll never get to work with because it's multicast and you can't use it on the cloud. So unless you're dealing with IP video like me, you won't be dealing with multicast. And even still, there's probably about 5 to 10 of us in the world that understand IP multicast, and we get pulled in for every single architecture throughout the world. So you can skip the class Ds. The class A's are the 1 to 126. The class B's are the 127 and 191. And the class C's are the 192 all the way to 223. Want to know an even bigger secret? When you're dealing with networking people, if I say a class A, we're referring to a /8. When we say a class B, we're referring to a /16. And when we say class C, we're referring to a /24. And we don't give a darn anything that relates to these rules. So for us networking professionals, class A always means /8, class B means /16, class C means /24, and everything else is a subnet. But good question. How many subnetting questions are in the associate test? Not more than 2. And here's the thing, 8th root. You may be able to pass the test with knowing nothing on subnetting, but you'll never be able to work without it. So that's kind of the big difference between certification capabilities and what you need to do to be in the job. Now, if you're a cloud engineer, you'll still need subnetting, but if you're a cloud admin, you may get away without it. But any of the professional jobs, DevOps, cloud engineering, cloud architecture, any of the bigger roles, you're definitely going to need to know how to do this. Mary's box, some of these concepts are going over your head. Here's the thing. We've got the book, we've got this course, and you can do it again and again. Now, realistically speaking, because this is a certification course, and that's why there's only so many things we can cover. Now, the subnetting piece is a little bit tricky, but it's also critical. And that's why, I had said we'll do an additional subnetting course, because for people that don't know this, I can't hold back the entire certification program for the week, but it's pretty important stuff. So, with that in mind, we're going to actually do a complete subnetting deep dive workshop to make sure that you have these skills, because it is so important. And just because we can't cover, things in this doesn't mean you don't need it. So we'll make a separate day and spend 3 to 5 hours on it and make sure you know it. How can you determine using, you'll be using IPv4 for everything until proven otherwise. So it's always going to be IPv4. Memories box. Yes, I can easily explain this. This is a fantastic question. So, love this question. Love this question. Love this question. So let's do this. Let's make this a little whiteboarding session and work through it. So how do I do this? I'm going to enter a slide here. Okay, so here's how we make the determination. We've got a router here, and we've got another beautiful router over here. And they want to talk to each other, so we plug in an Ethernet cable in between them. Now, on this link, and every link needs to be on a subnet, what are we talking about? How many addresses, and put it in the chat box, how many addresses do I need for this subnet, for this one router to talk to this one router? How many addresses do I need for 1 and 1 to talk to each other? 1 plus 1. How many addresses do I need? 1 plus 1. How many addresses do I need? Somebody tell me in the chat box. 2, exactly. So the first thing that I need to do is determine how many IP addresses I need, which is 2. So when we figure out the correct subnet side, we need to first think how many IP addresses we have. Now, the formula that we can use, quite frankly, is going to be as follows. And we can't get too deep into this now, but I can and will on a different workshop. So if we have a 128, a 64, a 32, a 16, an 8, a 4, a 2, a 1, okay, so this is, let's just work with this assumption for right now. This is 2 to the, so we'll just call this 1. So, because this could be either a 1 or a 0. Now this is 2. This is 2 to the second. This is 2 to the third power. This is 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, and 2 to the seventh power. So let's just say this over here is basically an IP network as it stands right now. This is a class C. As it stands right now, let's pretend this is 192.168.1.0, and let's assume this subnet mask is 255.255.255.0, because that's what that subnet mask will look like. Anybody want to know where I got this number from? Somebody help me. Where did I get this number from? Oh, oops, didn't mean to do this. So here's 255. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, 1. That equals 255, everybody. So if I need 2 hosts, what I need to do is I need to take some of these network bits and turn them into host bits. So there's a formula that's called 2 to the second minus 2, which will determine how many hosts. So in this particular question, how many network bits do I need to support? 2 hosts. So if we do, I don't even know what happened here. So let's go back over here. Let's bring this over here. So think about this one more time. We're going to play with this a little more. So now you see what we're really dealing with. This is the subnet mask. It's 128.64.32.16.8.4.2.1. That's how we got to one of these 255s. And before we go too far down a rabbit hole, because I'm a little worried we're going to do this, and we probably should do this in a subnetting thing. If we only need 2 addresses, we would go over here and say this gives us 4 addresses. Now remember, the first address on a subnet is the network, and the last address on a subnet is the broadcast. So here we'd see we have 4 addresses, but we lose 2, so this would be appropriate. Now, let's say we needed to put 10 hosts on a subnet. Which one of these things will give us 10 hosts? This will, if we go to here. So if we needed a subnet that would give us 10 hosts, what would we do? We would add the 128 plus the 64 plus the 16 plus the 32 plus the 16, and we get that. So realistically speaking, that's what we're talking about. We determine how many hosts we need per subnet, and then we pick it out. Here's a secret for you. Here's the secret. We need 2 hosts on a LAN link, and LAN links always get a /24. Why do they get a /24? Because it gives us 254 servers. And if you don't think you're going to need 254, assign 254 addresses anyway, because you're going to need it later. And if you don't assign it, you're going to run into problems. So what's the rule? What do we network engineers do in 99% of cases? /30s for WAN links, /24s for LAN links. I know that the question was going to take me in the weeds, but we'll dedicate a 3 to 4 hour subnetting workshop for that. So what was the next question? Will we cover an elastic IP address? Of course we will. Can you migrate public IP workloads from on-premise to AWS and retain the public IPs? No. And here's the reason why. You own the public IP for you. You own it. It's part of your internet service providers, as a rule, IP address space that you got from them. You can't put your addresses on the AWS network. They will give you a public IP address for you to use. Now, all you'll do is you'll just change your DNS settings, mapping it from the AWS public IP address to the new IP address. But anytime you move somewhere, for the most part, a different company, you're going to get a different IP address. What is the advantage of IPv4 over IPv6? None. There's major advantages on IPv6 versus IPv4, and that's why it was invented by the Internet Engineering Task Force. But we haven't migrated to it yet because it's newer technology. It's only 20 years old, and we're not using it that much yet. There's no difference in speed between IPv4 and IPv6. If your address is 123 Main Street or 456 Main Street, you don't get mail faster or slower. What else? Okay, so I promise you we will do a 3 to 5 hour subnetting workshop. We'll get it scheduled because otherwise it's going to go down and derail us. But it's very important content, so I want you to understand it. So what are we going to talk about? We're going to talk about the AWS VPC, which I like to call your own virtual private data center. The non-networking people would call it a virtual private network, but it's not exactly a virtual private network. It's more of a virtual private data center. So keep that in the back of your mind. So in this section, we're going to talk about some of the coolest stuff. Routing, internet gateways, NAT, external addresses, endpoints, VPC peering, access control lists, security groups. This is the party time. So I want you to understand one thing. So let's say we've got some people on this call. I'm looking at it right now. I see about 145 people on there. And the people want to communicate to each other. So how do you get from point A to point B, generally speaking? You build a map. So if I want to go to Abigail's house, here's what I'm going to do. I'm going to print out directions to Abigail's house because she's got a beautiful cat, Noni, and my cat, Cindy, and I'm sure they'd be friends. So our cats want to play. I print out directions to Abigail's house. It says, make a left, make a right on I-95 North, take I-95 North for 468 miles. Then get off at this exit, make a left, make a right, etc., etc., etc. Kind of keep that in the back of your mind. And so these are the kind of things that are kind of going on there. So as Chris said, 140, 50 people on there and only a small number of likes. If you can help us out by liking, commenting, and sharing, we'd be thrilled. But what happens is the routers are going to build a map of the network. So the way you build a map to go to your friend's house and print out directions, the routers build a map on how to get your traffic from point A to point B. The router's like a traffic director. Hey, information comes in here, goes out here, comes in here, goes down here, comes in this way, goes out this way. So a router is just a traffic distributor. Boom, 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 constantly, hot potato, boom, 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 boom. And that's what routers are doing. And the routers build the map of their interfaces, which says to get to Abigail's house, go this way. To get to Noni the cat's house, go this way. To get to Chris's house, go this way. To get to Leo's place in Brazil, jump on this airplane. To get to Chow's place in Dallas, get on this plane. So the routers build a map of the environment, and that's how they know how to direct your traffic. Kind of like an airplane. When you get there, get on this plane to go here, and get on this plane to go here, and get on this plane to go here. Those kinds of things. That's what we're really talking about. So what's created is something called the routing table, and the routing table is just a map. Now I'll show you what it looks like, but there's two kinds of ways we can build our routing tables. I can print out directions to Abigail's house. Make a left, make a right, go straight, make a left, go right, go straight for 500 miles, make a left, go right. Beautiful, right? Now here's what happens. I'm on the way to see Abigail's cat Noni. Beautiful cat, by the way. And on the way to see Abigail's cat Noni with my cat Cindy, the road's blocked. I have a static route. I manually tell me, I don't know where to go. I'm stuck. So we can build a routing table or our map in the following way. We could manually tell every router how to reach everything. Now, imagine an environment with 50,000 routers. Every time you change something, you go to 50,000 routers and you do it. Or we could be smart and we could use a GPS on the way to go to Abigail's house. And the GPS has a map of everything. And I'm on the way to Abigail's house to see our cat Noni. All of a sudden the road's blocked, and all of a sudden I hear recalculating. Make a left, make a right, recalculating. And then a little later, I show up with some fresh salmon, some shrimp, and some scallops, and our cats have a party together. So that's what we're talking about. We can build it dynamically with what's something called a routing protocol that will basically negotiate and exchange information with all the other routers and build a map on how to get there, just like your GPS. That's dynamic routing. Or we could do static routing, which is, hey, to get to Abigail's class, go here, print out your directions. So either case we can do it, and you're in good shape. So now let's talk a little bit more. Let's show you what a routing table is going to look like. Routers route based upon the destination subnet. So if you see something like this, here's what it's going to look like. You're going to have a subnet, and it's going to say locally connected, meaning it's directly connected. Then you'll have this subnet, and I'm not really sure how this just happened, and my computer did something funny, where it'll see this subnet, and it'll say target. That's the interface that it goes out of. Then you'll see another subnet, and it'll go out that. Now, notice this. This 192.168.0.0/16 and this 192.168.1.0 are both covered in this. But because this is more specific, the router will choose the more specific route to reach the destination. And lastly, you see this route that says 0.0.0.0. That's something called default route. And here's what a default route is. If you don't know where to go, go that way. So generally speaking, people do a default route to the internet, which is basically if you don't know where to send your traffic, go that way. Now, when we're dealing with dynamic routing, I mean, you're going to want to use dynamic routing. Here's what it typically looks like. There's two kinds of routing protocols. There's interior gateway protocols and exterior gateway protocols. And we cover this in much more depth on the free CCNA curriculum. And obviously, the students in our Cloud Architect Career Development Program really learn this because it's critical information. Inside your organizations run an interior gateway protocol, such as OSPF, EIGRP, or intermediate systems to intermediate systems. As a rule, it's OSPF in today's world for everybody. And they use that inside their entity, their organization, and be able to create reachability of their systems. And then organizations use what's called an exterior gateway protocol to connect different companies. So company A is, they run OSPF internally, and they want to connect to 4 internet service providers. So they connect to their internet service providers via BGP, an exterior gateway protocol. You connect to AWS, they're an exterior organization from you. So you connect to them with an exterior gateway protocol. So the key is interior protocol inside your organization, exterior connecting to others. Is AWS your organization or somebody else's? They're owned by somebody else. So since they're owned by somebody else, you connect to them via BGP. BGP is used for lots of reasons, and we'll talk about why BGP is used for lots of reasons. And a discussion of BGP is far outside of the scope of the Certified Solution Architect Associate, Certified Solution Architect Professional, and AWS doesn't even begin to cover it with an advanced, and they're in the advanced networking. They just say, don't worry about it. But you must know this to be a cloud architect. So we have lots of BGP training videos on our website. And of course, we're always going to do periodic webinars on that too. Love training people in BGP, train lots of engineers, architects throughout my career on it. So the point is, we're using BGP because it's tunable, it's scalable, and it's how you connect to an external organization. So AWS does support, dynamic routing via BGP. So basically speaking, if you've got a direct connection or a VPN, you can run BGP to them, exchange routing information, and kind of have that cool dynamic map. Now, when you're using BGP, it's not like other routing protocols. Most of those other routing protocols are designed internally, and they multicast hellos and things to each other to find them. So that's the way the rest of the protocols work, but not so with BGP. BGP is a TCP-based protocol, and it runs specifically on TCP port 179. Okay, TCP port 179 is BGP. BGP is TCP port 179. BGP is TCP port 179. Yes, it is a test question, which I don't care about. But why do I care that BGP is TCP port 179, that I've said it a whole bunch of times? Well, because if you have a firewall and you don't enable BGP TCP port 179, you won't be able to reach anything. And let me tell you, I have seen more problems from people that didn't know to open TCP port 179 on all their access control lists and their firewalls, and they broke their system. So BGP runs upon TCP port 179. Don't forget that, because it will save you so many things and mistakes in your career. BGP enables load sharing, so you can have multiple connections to the cloud. And when you use BGP, you'll have to have an autonomous system number. Now, we've got lots of videos on how to use BGP, and some of my team can pop them in the chat box. And we've got an article we wrote on BGP as well, which we can pop in the chat box to kind of help you guys out. But if there's a desire, I'll do another BGP workshop, because I love BGP. So remember, BGP is going to be required when you have a direct connection. But here's the thing. BGP has so many tuning options. And in one of our things, you'll see how we can use BGP to securely connect, to send some routes, not all routes, to traffic engineer, to load share across direct connections, to really do things. And we can tune things like the weight, the local preference, the AS path, the origin code, the multi-exit discriminator. Now, when we're dealing with AWS, you got to remember, their BGP implementation is very basic. It's very limited. For example, when I connect a company to 3 internet service providers and I need BGP, typically speaking, I take in about 800,000 routes per internet service provider. So together, I'm getting about 2.5 million routes from 3 service providers. AWS says we can take 100 routes. So for people like me that are used to working with 800,000 routes from multiple internet service providers, now it's like AWS, like, here's your 100. It's nothing. So when you use AWS, you've got to have really good IP addressing. And your IP addressing has to be so good that you can get such good degree of route summarization that you'll be good to go. Now, having said all of that, we'll see all of that in the subnetting workshop that we're going to do. You can go look at the old one right now. But in the meantime, I will do another multi-hour subnetting workshop, and it's going to be lots and lots and lots of fun. Okay, so now we talked about what is BGP, et cetera, et cetera. So the next thing we're going to talk about is an internet gateway. Well, before we get into the term internet gateway, let's just talk about what a gateway is. A gateway is a router. That's it. It connects you somewhere. What is the default gateway on your computer? It's the router that you use to connect to the internet. So what are we talking about? Default gateway. So now you know what that is. So when we talk about an internet gateway, which is what we're going to talk about next, actually, before we get to the internet gateway, let's go to the internet gateway next. So an internet gateway is a router that connects to the internet. That's it. In your organization, you've got a router that connects to the internet. That's your internet gateway. In AWS, if you want to connect to the internet, guess what? You got an internet gateway. Now, when you get an internet gateway with AWS, it's a logical high router, meaning it's not physical, so it doesn't go down. As long as AWS is up, they don't go down. Now, theoretically, they say there's no bandwidth constraints or performance limitations. There's always performance constraints and bandwidth limitations, and you'll know it when you run up against it. But really, it's just a router that connects to the internet. So if you've got something you want to connect to the internet in AWS, and I mean real internet connectivity, you're going to need an internet gateway. And what do I mean by real internet gateway? Internet connectivity. If you want a device like a web server to be reachable from the internet, it must be on the public internet, or at least the load balancer part of it has to be. That is things that are on the real internet. Now, it's completely possible to have your systems behind a firewall, not reachable from the internet, but they can go out to the internet and let their return traffic back to go to the internet and patch their systems. That's not what we're talking about here. An internet gateway is to get real internet access, bidirectional, outbound and inbound, outbound and inbound. So that's what internet gateway is for. So when would you use an internet gateway? When you want to get your stuff reachable from the internet. And the way this will work is you'll attach an internet gateway to your VPC, which is basically a virtual router that goes to your virtual data center. You'll then create a default route that says when you don't know where to go, hey, go out the internet gateway. You'll then pop a public IP address on either the web server, the load balancer, based upon what you're doing, and your systems are going to be reachable from the internet. Woohoo! Well, wait, your systems are reachable from the internet. Uh-oh! Now they're open to hacking. Open to hacking, open to hacking, and open to hacking. So now you know how to deal with that. So let's look at what an internet gateway really looks like as we're going through things. What you can see, what we have here is we've got our servers internally, and our internet gateway is really kind of what's just going on over here. And this is a router which we're using to represent going to the internet. But realistically speaking, the internet gateway is here, but this is the virtual router for your VPC. But you point is you got a default routing your routing table that says all unknown traffic go out the internet. And you can see what we have is a private IP address internally being mapped to this external IP address. And note, if you've got 1, 2, 3 web servers, they all can't have the same address unless they have a load balancer. And the load balancer will have those addresses, and these things will be sitting in a private. So what we're talking about there is internet gateways, which is full, inbound, outbound, all kinds of cool internet connections. And the next thing that we'll do before we take a little break is we'll talk about egress-only internet gateways. So what is ingress? Ingress is coming in. Egress is going out. Ingress is coming in. Egress is going out. So an egress-only internet gateway is an egress-only means it allows your outbound traffic out and your return traffic in, but it doesn't allow access from the outside world. So internet gateway, I've got a web server here called www.gocloudcareers.com. The internet gateway reaches my server, www.gocloudcareers.com. Gocloudcareers.com responds, sends it to the internet gateway, and sends it back to you, and everybody's good. Now, an egress internet gateway is the exact opposite. An egress internet gateway is for IPv6 only. And since in IPv6, all addresses are public, there's no concept of NAT, which we'll talk about later. So an egress-only internet gateway allows organizations and companies that use IPv6 addresses to go out to the internet and let their return traffic back. I want to go update my Apple operating system. I go out and it allows it back. So what's going on here is we've got something watching the state of the connections. And it's saying, hey, wait, that's Chow. She's behind the firewall. She's going to www.gocloudcareers.com. Chow's traffic escapes through the firewall, goes to the internet, and gets answered back, and allows the return back. So that's an egress-only internet gateway. So internet gateway, in and out. Egress-only allows your outbound traffic and return, but no inbound traffic. And keep that in the back of your mind. So let's take a brief pause there, see if anybody has any questions. and then we'll go back into some more of this cool VPC stuff, which is where all the fun is. So what do you call it? If there's any questions, let me know, and if not, I'll go back. CSL, AWS provides an IP address, v6 address on every interface unless you shut it down. So you get both IPv4 and IPv6 addresses in AWS. But for the most part, everybody's just using IPv4. Ciao, here's when I use a static route. And it's very limited that I will ever use a static route. If we have one connection to the internet, only one, then we can do a static route to the router that connects to the internet. But here's the reality. In real life, we got to be crazy to have a single connection to the internet, because when that internet connection goes down, we've got no internet connectivity. So if you want to use more than one internet connection, you're going to use dynamic routing. Now, Chow's question is so good, I'd like to explain this. So let's imagine this. Let's imagine I have a primary path, a secondary path, and a tertiary path. If I don't use dynamic routing when the primary, so let's say it looks like I've got a cable and it looks like this, one of my Apple keyboard things. So let's say I've got this cable and I've got 4 backup paths. In a dynamic and routing environment, if this cable is cut, I still have this one, and this one. So I use dynamic routing. If I use static routing, because I only have one cable, if it's not here, go here, and the link goes down, it doesn't matter. But if I've got 3 links, or 4 links, or 6 links, I use dynamic routing, and that way the dynamic routing can self-heal itself. So for the most part, we're almost exclusively using dynamic routing. The only time we would do static routing is in a really, really tiny network, where basically you just pop something there. Now, I'll tell you, a lot of people do static routing to AWS because they don't know networking. And in the end, hold on, whoa. Hold on one second. I don't even know how to get rid of this. My wife's music. Sorry about that. Somehow my wife's been downloading music like crazy. I accidentally pushed the iTunes button, and the next thing I realized, we're hearing Dancing Queen from the 1980s. Wow. Well, anyway, it was fun disco time in those days. But anyway, let's go back to the next question. What is the relation between VPC and subnets? Absolutely nothing. And what is the two? So here's the thing: your VPC is your virtual private data center. And data centers have routers, and routers route to subnets. So if you walk into any data center, cloud or otherwise, you'll have a subnet for marketing, a subnet for sales, a subnet for this service, a subnet for these servers, a subnet for these servers, a subnet for sales, a subnet for engineering, and you need a router to actually route between them. So in the data center, you have a router that does it. In the virtual data center, you have virtual routers that do it, but it's the same thing. What do you need to consider at the network level when you're using hybrid or multi-cloud or single cloud? A whole lot. You need to be able to think about what your IP addressing scheme is, what routes you can summarize to whom, what routes should be shared with whom, because if you don't have a route, you can't hack it. So who do you share your what routes with? Do you want your routing to be transitive or not transitive? Do we want to be load sharing across connections, in which case we need to leak certain subnets over certain things? What do we want our primary traffic to look like on the way to the cloud? What do we want the backup traffic patterns to look like on the cloud? How do we want to replicate our data to further offsite things? So there's a lot more things than that to cover. In fact, I will tell you, Naga, that I've spent 25 years doing just that, only thinking of that, and I've only scratched the surface after 25 years. So I could fill up about a 1,000,000-page book of all the things that actually these cloud network architects need to do in here. So it's everything from knowing the right IP addressing scheme, to knowing where to summarize and when to summarize, to knowing which routes to leak and where, to know which routing protocols to use, whether you use Ethernet MPLS versus software-defined networking versus a private line versus various VPN connections, what the addresses need to look like, how to prioritize traffic, how to use queuing so you don't deal with the worms and viruses, how to do things like MAC address authentication. So those are just some of the many, many things that you can consider that would go into being a cloud network architect. But even a cloud architect, you need to know that many. And truth be told, Naga, that's why our cloud architect training program is 500 hours and it's not a certification training program, because it really takes that much. And if you'd like to know more, we'd love to work with you. Where do you configure ingress and egress, Cecile? Management console, CLI, or API? Can I extend stateful and stateless services? Sure. So, stateful watches. So let's pretend my iPhone over here. Let's pretend this is a firewall. So I go to www.gocloudcareers.com. I'm behind the firewall. I breach the firewall, and the firewall sees Mike Gibbs is going to www.gocloudcareers.com because he wants to become a cloud architect. So I go to www.gocloudcareers.com. I pierce the firewall on the way out. Now the firewall sees Mike Gibbs is going back to www.gocloudcareers. And Nina, when I try and initiate a web connection, I do a SYN or a synchronize with the GoCloudCareers web page. Now, GoCloudCareers web page is going to acknowledge my SYN with an ACK, and they're going to send a synchronization to open the second set of the connection with me. So when GoCloudCareers website responds and the firewall sees it, the firewall sees it's gone on and it's going back to Mike Gibbs. Mike Gibbs requested GoCloudCareers, and Mike Gibbs is allowed to get GoCloudCareers. Now, by comparison, Nina, GoCloudCareers just tries to come in on its own, but nobody requested it and it's blocked by the firewall or dropped. So stateful means something is watching it. Now, by comparison, stateless means there's no state. So let's pretend instead of using a stateful firewall here, we used an access list, which is just something dumb. The access list would look and say, okay, Mike's packet is allowed to go back. And then the access list would look and say, is the return traffic allowed? And it would not be allowed in unless we enabled it on the way in with the access list. And the reason it would not be allowed in is the access list is not watching to see what's going on. It's not holding state. So that's why access lists provide minimal security protection, because we either block everything or we have to open up big things where stateful appliances that are watching things like a firewall will do that. So state is keeping track of what's going on, and it's a fantastic question. When using dynamic routing, what kind of IP configuration would I use? I would design the IP configuration route based upon what it needs to be for the customer, based upon how many addresses I need somewhere, how, where, and when. So that's up to the network architect, and there's a lot of skill that goes into that. Any others? Can I explain when a load balancer is used with an internet gateway? You should not be using a load balancer with an internet gateway. So there's routers and routing protocols that you should really be using to load balance things. Is transitive routing possible? Absolutely. So NIWI keys, we're going to get there. So IBGP is not transitive until we create route reflectors. And guess what? We're going to be creating route reflectors here. Chenton, good question. What is the difference between an API gateway? An API gateway is the way you talk to an application. An internet gateway connects you to the internet. And news. You will need firewalls, IDS, IPS systems, access lists, security groups, host-based firewalls. You'll need to harden your systems by disabling unnecessary services, putting further anti-malware protection amongst the list. The WAF, Shield, and network access lists and security groups is not security. You're going to need about 1 million times more than that if you're dealing with a big company or something more than that. So it's not which, either or. It's how many more in addition to all those do you need, which is a lot more. Basically, you create a route to it. So that's all you're doing is you're creating a route to it. Soothing relaxations, what I say dynamic routing is safer than static routing. It depends on your network engineers. If your networking team is bad, a static route is 1 million times safer, because if they configure the routing protocols wrong, basically your traffic's going to be going in circles forever. And soothing relaxations, I'm going to tell you this, 50% of my career was chasing traffic that was circling forever, because what happened is somebody that thought they were a network engineer, they were like a Linux admin or a programmer, decided to put IP addresses on things, and it caused outage after outage after outage. So the safest and the best thing to do is to make sure you know networking before you actually determine what the routing is. Otherwise, it'll turn into an absolute disaster. So a couple things I want to mention. If you like to do the hands-on element of this training, please download the special lab access. We created a special lab course for you, and it's completely free. The link is in the description below. Now, vote for our next boot camp. Do you want us to teach an Azure training or a Google training? See, here's the thing. All clouds are the same, but we like doing training sessions. So what do you want to learn, Azure or Google? Vote for the next one, and we'll give you a great, fun boot camp. And if you can put the hashtag cloud hired in the chat box, and even an additional hashtag after that that says where you're from while you're at it, 2 hashtags would be perfect. The cloud hired, and actually, you know what? Cloud hired and your geography. I love knowing where everybody's first. And there's a place to vote for the next boot camp. The link is in the description below, so make sure you vote on it. Philadelphia, that's a place I have spent so much time in. So now let's talk about NAT instances. Now, NAT instances were something old, and AWS no longer recommends it. But guess what? They're still valid, so we're going to tell you. So a NAT instance is a virtual machine that does NAT. What is NAT? It's when you take one address and translate it into another address. English to Greek, Greek to English, Arabic to English. That's NAT. French to English, German to English. It's NAT. We're just translating one address into another address. Now, there's a lot of use cases for NAT. NAT could be used to connect to the internet by translating a private address to a public address. NAT could be used by, if Abigail has the same address on her computer or her cat's computer, Noni. So if Abigail's computer, Noni, has 172.16.1.1, and Cindy the cat's computer is also 172.16.1.1, and they want to talk to each other, they can. But Cindy can translate her address into 192.168.1.1, and Noni can still be 172.16.1.1, and they can have a beautiful conversation. They can talk about cat food. They could talk about eating shrimp, chasing down animals, cleaning their fur, or whatever cats would talk about if they were together. So, you know, these are the kind of things. So a NAT instance is a virtual machine that lets you translate one address to another. Now, a NAT instance allows for egress-only internet access. So what does it mean? It enables you to go out to the network and pull it back, but it means you are not open for external connections from the network. So what does that mean? What does that really mean when we think about it? It means your systems are somewhat protected. Nobody can go in and reach them. So a NAT instance is a virtual machine that enables you to translate from public to private. I mean, private to public. Egress only. So what do we have so far? We've got an internet gateway, connect you really to the internet. So your stuff's reachable from the internet, and you can go down to the internet. We've got an egress-only internet gateway for IPv6, right? That allows IPv6 systems to go to the internet and allows their child back. Now, the last one is as follows. We've got a NAT instance, which is now an IPv4 way to translate one IP address to another. And then, and it looks something like this. Realistically speaking, you've got your private subnet, you got a virtual machine called the NAT instance that then goes to an internet gateway. So now you know what that looks like. And then AWS basically said, you know what? People struggle. People can't figure out how our stuff works. We're giving them 10 hours of training, and we're asking them to, and don't explain how anything works. And we think people need to do this. And they found out that people couldn't. They embedded a NAT gateway. And what's a NAT gateway? A NAT gateway is a way to take some of the complexity out of this. And a NAT gateway is a fully managed NAT service. So it means it's redundant or high availability because it's logical, not physical. And what happens is, as soon as you create the NAT gateway, it's going to take a public IP address, an elastic IP, and it's going to use that as the public address. Now, a NAT gateway does something called NAT overload or PAT, port address translation, and it translates a whole lot of internal addresses to a single external address. So what does that mean? It means your internal systems are not reachable from the internet, but they can go out to the internet all the time. So what are you going to do? Basically, you're going to create a default route, the NAT gateway. Now, every availability zone should have its own NAT gateway. I'm going to say this again. Every availability zone should have its own NAT gateway, because 1 is none, 2 is 1, and 3 is a whole lot better than 2. So systems, NAT gateway. Now, NAT gateway by itself does the same functionality as we had before with the internet gateway in that instance, but it's all in a single device and nice and simple. So next thing we're going to talk about is an elastic network interface. God, I hate this term. I think this is the worst term I've ever heard that adds more complexity. What is a network interface? A network port. Your computer has an Ethernet port. That's your network interface. You got a computer, you stick 10 Ethernet ports cards in there. It's got 10 network interfaces. A network interface is just a network card. Now, in the physical server itself, we've got physical network cards, everybody. But under certain circumstances, like really more certain circumstances, we might put 10 subnets on a server. And if we do, the server can be on multiple subnets. The server will route between subnets. So kind of keep that in the back of your mind. All an elastic network interface is an interface. So if you go to a virtual machine, a VMware virtual machine, and you want to add 3 NICs, that's what you're talking about, elastic network interfaces. So it's just an interface. Now, every device has an interface. There are some people that will put a public interface and create the most dangerous security violation in the world called the Bastion host, where you connect to something on the internet and you have a backdoor in time of your system. That's where you would have 2 network cards. But we strongly recommend never to make a Bastion host in your entire life. If you make a Bastion host in your career, chances are your replacement will thank you for the really good architect job. So we strongly don't recommend a Bastion host. There's a video from my team on why you would never, ever, ever use a Bastion host in real life unless you did something wrong on the channel, which you can watch. But a network interface is a system that has a card. So you can put 2 network interfaces in your system or 10 network interfaces. By default, all systems come with 1 network interface, just like your PC. Buy a workstation instead of a PC, it's got 2 network interfaces. Buy a regular computer, it's got 1 network interface. Same thing. So that's an elastic network interface, meaning it's just a network card, nothing else. Okay, so an elastic network is an IP address. What's an elastic IP address? So AWS decided to call a public address an elastic IP address. If you use the term elastic IP address with your customers, they will laugh you out of the room. So I strongly suggest you don't do it. An elastic IP address is a public IP address that you can borrow from AWS. Your customers will know the term public IP address. They will laugh at the term elastic IP address. Don't use it if you talk to your customer as an architect. If you do, your customers are going to assume you're trying to sell stuff as opposed to seeing you as a trusted advisor. So an elastic IP address is a public IP address. See, anytime you're in a public, your systems need to be reachable. You need a public address. Now, what we used to do, we would go to our internet service providers and Aaron and Ripe. We'd ask for an autonomous system number, a public address, and we'd get it, and we'd use it. And we still do that in the data center every day. But when you're on AWS, they made it a little easier for you. And to be fair, the cloud is all about taking things that are really, really great and wonderful and simplifying them. That's why we're all in the cloud. It simplifies the complexity of the traditional network in the data center, and we trade agility for performance. But the cloud's worth it for 99% of the people. So we need an elastic IP address or a public IP address, and that's it. So instead of buying your own, when you want one, you ask AWS for a public IP address. Get your public IP address, and you keep it until you don't need it anymore. So you're basically borrowing the public IP address that AWS owns. Then that's what they call an elastic IP address. So what's it really look like? Let's pretend this router was a load balancer in this particular situation over here. and this was the front-end IP address for the whole internet. The elastic IP address would be on the front end of the router or load balancer. That would be the public address that the rest of the world would use. Now, when we get into the cloud, we start getting into this concept of endpoints. And an endpoint is really a way to connect an organization's virtual private data center, or VPC, to other AWS services or other organizations over the system. And the reason we use endpoints is as follows. Let's say we are on the cloud. We're here on the AWS network. And our customers also on the AWS network. We have two choices. We could leave the AWS network, go over the internet, and come back on the AWS network and reach our partners. We could do that, right? Now, we have to pay to go to the internet. And when you go to the internet, performance is not guaranteed. The internet is not secure. So we could choose to take our traffic out of the AWS cloud, across the internet, and back into the AWS cloud. Or we could just send our traffic across the AWS cloud, exactly, because we're there and our peers are there. Now, that's what endpoint communication is. Endpoints enable you to reach something on the AWS network. So, is internet performance guaranteed? No. Is internet latency guaranteed? No. Does AWS have control over their networking performance? A whole lot better than the internet. So, by using VPC endpoints, we get better performance, lower latency, higher security, and lower costs. So that's how we're going to be connecting things. So let's look at an example. Here we've got our VPC, which is our data center. Here we've got the AWS object storage, S3. We want to put our stuff into object storage. Well, two options. We leave our VPC. This is egress traffic, which we pay for. We send all our beautiful traffic over the internet, which means we've got to encrypt it. And then we come back into AWS and stick it over here. This is slow and expensive. This is terrible. Or we just create a VPC endpoint and we go straight from the VPC to S3 and we're done. That's my choice, and that's what an endpoint is. That's what endpoints do, how they work, and why we use them. So let's get into a little bit more about VPC endpoints. Realistically, they're virtual devices. And what does virtual mean? It means they don't go down, so we can consider them to be reliable. Now, they're highly redundant and they scale very, very well as a rule. Now, when we're dealing with two kinds of endpoints, gateway endpoints and interface endpoints, and they work very differently. A gateway endpoint is a high-speed endpoint, a high-security endpoint to an AWS service. Generally speaking, think about things like S3. And the way a gateway endpoint works is it's going to place a route in the routing table to whatever it is that we're looking for. And so if we create an endpoint to S3, we'll see some weird thing popping up called the prefix list, and it'll have like a PL-XXXXX, and that'll be your information. That'll be how you get the route to your endpoint. So it's going to work via regular routing. So how do you set up endpoint security? Well, a couple of things. Cindy and Noni want to talk to each other, Abigail's cat. Abigail's cat and Cindy don't have a route to each other. They can't talk. They're sad. So easiest way to lock your systems, don't give the route to it and you can't be hacked. If you don't have a path, you can't get there. It's kind of like right now. I get an amazing student from Bulgaria and Scandinavia. Let's say I want to go visit Eva Dykir. She's amazing. Well, I can't get in my car and drive to her. Why? Because I don't have a route. I can't drive over the ocean. Can I go visit my friend Eva Dykir? No, I can't. I can't reach her. So same thing here. Don't put a route on the routing table and you can't reach it. Now I could jump on an airplane. I could do all kinds of things, paddle a boat across the Atlantic Ocean, et cetera, but you get the point. If you don't have a route to it, you can't reach it. So limit your routing information. Of course, you can do endpoint policies, IAM policies, and all kinds of things. I'm just saying the network is your best security. Start there. Now, if a gateway endpoint takes you to things predominantly S3 and DynamoDB, what does an interface endpoint get you to? Other AWS services, such as the EC2 Systems Manager, Kinesis, Load Balancer APIs. But an interface endpoint is very differently than a gateway endpoint. Gateway endpoint puts a route on the routing table. Interface endpoints are actually local to the VPC. In fact, what happens when you create an interface endpoint, it creates actually another network interface or an elastic network interface in your VPC. And when you create this interface endpoint, it'll basically create the subnet interfaces on both sides. And what'll happen is you'll have the endpoint configuration, and they'll talk to each other. And by talking to each other over the endpoint, you've got a lot more secure communication. So what it does is, and I'll show you what it looks like graphically, is in this particular environment, we've got an endpoint that we want to connect to. So you can see we've got this secure endpoint, which is reachable from the opposite side. And this little link between the two, this link between the VPC and the VPC, that's technically called private link. And what is private link? It's the equivalent of a pseudo wire or a pseudo connection between your entity and the other entity. It's a virtual connection that rides the AWS private network. So if we talk a little bit about a private network. Now we're going to get into something fairly complicated called VPC peering. Chris, how many minutes has it been since we took our last break?
I was not keeping a timer for that.
Okay, let's do this. Before we get into the VPC peering, let's see if there's any questions, because I feel like now's a natural time. Explain how NAT on-prem is transferred to an AWS instance. It's not at all. So on our routers, we've got a Cisco router, for example, a Palo Alto firewall. We translate our private IP addresses internally to a public IP address. Now, in AWS, if we want to do that, we can do it with our firewall easily. Where else could we do it? We could do it on a NAT instance. We could do it on a NAT gateway. So basically speaking, in the data center, we use our router to do it, our firewall to do it. On the cloud, we can use the firewall to do it or the virtual router. It's identical to CyberMommy. The only difference is which device you're doing it on. And on tomorrow's premiere, we're going to talk about why you should never use a Bastion host. And I got to tell you, I've seen some certification providers teaching Bastion host. And I'm going to tell you, a Bastion host will get most people fired from their job. So we don't want anybody creating a Bastion host. And the Bastion host will most likely get your company hacked. So we want to talk about that. So join us on the show tomorrow, amongst lots of other critical security things. Isn't that gateway more of a firewall? Well, not exactly. It's doing the NAT functionality of a firewall, but it's not doing all the cool security stuff. It's not looking for patterns of behavior that are inappropriate and shutting it down like you get on a next generation firewall. It's not giving you that cool stateful kind of stuff where you can, create your demilitarized zones. It does have some state, but it's a different kind of stateful. So no, it doesn't. It's more of a NAT device than it is a firewall. But good question. Does lack of knowledge to a customer when they set up their network, will it cause a cloud outage? Absolutely, all the time. I have dealt with 25 years of outages, and I'm going to tell you, 99% of the outages were never related to someone that didn't know how to develop their code. It didn't have anything to do with anything. It was almost always exclusively somebody didn't understand the routing, IP addressing, subnetting, supernetting, BGP, OSPF, or the right kind of WAN technologies. I've seen it take down customers. It's the biggest cause of problems. By the way, people that didn't even understand routing gave Facebook an 8-hour outage. And if you believe AWS when they tell you that they had an 8-hour global outage due to an impaired network, it's because somebody made a network problem. And Google Cloud last year went down due to a BGP configuration error. So pretty much you've had all your major cloud providers and your biggest companies in the world go down by making BGP mistakes. So it's always networking. No network, you've got no cloud. Good question. It can cause you an outage or your vendor an outage or both of you. Is a load balancer considered a router? No, a load balancer is a load balancer and a router is a router. They do totally different things. Routers route based upon destination subnet. Load balancers only load balance between servers or firewalls. Yes, Chow, if you like the bootcamp so far, please smash the like button. Subscribe, tell a friend, hit the bell. Please, please, please share it with your network. Thank you, Chow. And yes, definitely say no to Bastion host. Never, 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 never. Bastion host is one of those mistakes that 20 years ago I tried to make with a buddy of mine. And while we sat on the chief information security architects, and we were both distinguished architects, and they said, you made a Bastion host. And we said, yeah, we know. We wanted to use our Red Hat Linux machines because your VPN concentrator doesn't support it. And the CISO said, Mike, how long is it going to take to hack into this? And I'm like, I don't know, you want me to try? And he said, no, I'll do it. And he hacked through the Bastion host into the corporate network in less than 10 minutes. Now, I got to tell you this. I've seen good hackers break through a Bastion host in 3 minutes and get into the internal network. Now, why is it done? Well, I got to tell you, it's not being done by anybody. Now, Microsoft has a different kind of Bastion host service, and it's good. The only people that do the Bastion host or teach it are the certification providers that have clearly never worked in this industry, or they wouldn't be doing it. So you'll never see a Bastion host in real life, except in a certification classes. And I need to put a public service announcement everywhere. Do not do this or you'll be fired. Do not do this or your company will lose billions. Do not do this or you may make your company bankrupt. It's that dangerous. So there's a video on why. But I've seen a lot of bad stuff in technology over the last couple of decades. In today's world, you only use the internet gateway. In fact, AWS is getting rid of their, I'm sorry, you get in, okay, so not gateway for internet network, very clear. Internet gateway, you want your systems to be reachable from the internet, like a web server. If you need to be reachable from the internet, you need an internet gateway. Now, if you don't want to be reachable from the internet, but you still want to go to the internet, so why might that be the case? Let's say you've got 100 systems behind your firewall. All of a sudden, there's a new vulnerability in the operating system, and you want to upgrade it. That's why you use a NAT gateway to go out there, pull your information, and come it back. And if you see a test question that says, on the Certified Solution Architect, Associate, or Professional, you would like to use something that will enable your systems to reach out and update their operating systems, but they won't be reachable from the internet, the answer is always going to be a NAT gateway. If you've got a web server that wants you to be reachable from the internet, that's always going to be an internet gateway. Hope I answered your question there. Great question, by the way. James, good question. Everybody has their own idea and version of an endpoint, and they're all pretty much the same. Just the names have changed. How do you cope with the changing IP addresses? The IP addresses don't change. The subnets don't change. A single IP address changes. Routers don't deal with single IP addresses, but they actually deal with the whole subnet. So if you've got a 192.168.1.0 subnet, which gives you systems 192.168.1.1, 1.2, all the way to 1.254, guess what? If one of those goes down, the router's not even going to see it because all the router's going to see is the 192.168.1.0/24 subnet. Good question. No, load balancer is not a router. Okay, so here is I'm going to ask this one last question. How long should I have used the services and how long should I study for the CSA test? I spent 2 days to pass the Google professional exam, but I knew the network in the data center, so knowing the cloud was easy. So I read a Cybex book. 2 days later, I passed the exam. How long should you study for the ACSA test? I know people that can do it in 1 day, and I know people that can do it in 2 months. It's totally up to you. How fast do you learn? So, how long have you used AWS services? It doesn't matter. So if you're an architect, you're going to be more on the system design side. So you're not going to be configuring the services anyway. If you're a cloud admin, you better be configuring those services for a long period of time. If you're a cloud engineer, you better be configuring those services for a long period of time to actually be able to get hired. But if you're a cloud architect, it's more about your design skills, your leadership skills, your SAN skills, than your hands-on. So it's really going to be dependent upon which career you want, which will give you this answer. Now, Lachlan, I think that's such a good question that tomorrow between 9 and 11, we will come online for 2 hours and ask any career question you have, because I want all of you getting your first cloud architect jobs, cloud engineer jobs, cloud admin jobs, whatever it is you want. So I'll come online tomorrow morning for 2 hours and answer that. Oh, wait. We don't have a 9 o'clock thing tomorrow? Oh, I'm sorry, tomorrow morning. We don't have that. We actually have a premiere. So either we'll be doing it after that. Okay, so okay, Chris. So I think the last question that was asked is the architect class more hands-on. The architect class is entirely different. This is the name of a service, how to configure that service. This is certification. In the architect class, we will teach end-to-end system design because that's what architects do. We'll teach the deep networking because that's what architects do. We will teach how to sell the product, how to design the product, how to do it. And in our architect class, we're going to have you have a bigger hands-on set of things, but they're different hands-on things. Because cloud architects don't configure the cloud, the things we have you do are building and designing your own clouds from scratch in our architect class. And that way, when somebody else is like, here, I did this little thing that an 8-year-old can do, our students have real things, know how to design and build clouds and multi-clouds. So soothing relaxations, our regular thing is about 1,000 times deeper than this. But that's why that's an architect program. This is a certification course. They're very different. Both are needed. Certification gets you an interview. What we teach gets in the architect program is how our people get hired. It takes both. Something for getting an interview, which is certification, but nobody gets hired based upon certification. They get hired based on competency. So, those are the things we teach, how to do the job. So going back to our content over here.
Hey, Mike, let me interject real fast. There's a mix-up on my part about tomorrow. So okay. Tomorrow we have the premiere of the video at 8 o'clock.
Okay, perfect.
And then immediately after that, we have our Q&A session. So there'll be like a quick switch over between the two. So we still have our Q&A session tomorrow.
And yes, you need salesman skills to be an architect. You won't get hired without it. You will need executive communication skills and all of that. Absolutely. This is not a back-end job. The architect job is a front and center. You'll be designing things, selling billion-dollar architectures, presenting at conferences, being interviewed by the press. I mean, you name it, that's the job. So it's not a technical job. You'll need executive skills, sales skills, negotiation skills, all of it, all of it, all of it. So let's get back into the technical content here. So when we want to connect one entity to another entity, we kind of have two ways we can do it on the AWS cloud. We can do it with private link, and we can do something called VPC peering. Now, they're both valid and they're both different things. So let's talk about what those two are. Private link is basically just a wire between you and somebody else. So interface endpoint, two connections between you and somebody else. Works great. Now on an interface endpoint, share port 22 between them. Sure, share port 443 between them. Only allow traffic in but not out. We can do that with private link. So private link enables us to connect to a very large number of external entities. So imagine I'm a computer manufacturer and I deal with 15,000 parts vendors. I deal with MSI, I deal with EVGA, I deal with Corsair, I deal with Micron, I deal with Samsung, I deal with Hyundai, I could go on forever. If I'm this, and all my customers are also all on AWS, all I can create is a private link connection to each one of them. And our systems are all talking to each other, and it's great. But what if I want more communication between each other? I've got other options too. So we'll kind of keep this back. So when we're dealing with private link is useful to connect two entities to VPCs if they have overlapping IP address. So when Cindy the cat at my house wants to call Abigail's Noni the cat, and they want to get together for shrimp and scallops together at a big party, and they want to wear their little cat birthday hats, and they wear t-shirts that say allergic to humans or something like that. For example, we got these two cats. They're going to communicate. They're going to connect to each other. And now remember that Cindy the cat and Noni the cat had different IP addresses. No worry. We use private link and it automatically translates it for us. It does not. So private link provides network address translation along the way. Private link supports overlapping IP address. Private link does all kinds of stuff. Private link is cool. So kind of keep that in the back of your mind. Private link uses NAT, so there's literally nothing to worry about with regards to overlapping IP addresses. And now you know. So private link is unidirectional. So how cool. Abigail's cat is selling cat photos. You can just see the cat photos and nothing else. You can't find anything going on Abigail's cat, just a cat photo. So that is private link communication between entities. Now let's say we want something else. Let's say I'm a company and I buy another company. I have www.gocloudcareers.com. And let's pretend there was somebody that made some kind of quality training out there that was good and it was strong and it was innovative and it was something that could change people's lives, and we decided to buy them because we only want the best. Well, if I'm an entity and there's another good entity that's really good, guess what? I'm going to connect them and we're going to share all these other things. And when we when we share the connections between us, we share everything. So now me and my company and this company, we're peered. We're talking to each other. So this is beautiful. VPC peering is a way to provide connectivity between each other. Now, VPC peering feels a whole lot like IBG peering for people that are used to IBGP, in that it is not transitive. And what that means is if this VPC tells me a route and I don't tell the next VPC a route, then these two can't talk to each other through me. So, VPC peering is non-transitive. For any of you network engineers that have worked with IBGP, you know exactly what I mean. For you non-network engineers, I will show you some examples coming soon. Now, when you're dealing with VPC peering, any kind of inter-region traffic is going to be encrypted. So here's what you use VPC peering for and what it looks like. In this particular environment, you can see we've got one customer and we've got another customer, and they talk to each other via VPC peering. So VPC peering is not transitive. So for any of you IBGP people, you know exactly what the problem is next. For those of you that don't, we'll go over it. We have two architectures we can use. One is called hub and spoke, and one is called full mesh. In a hub and spoke environment, which is going to look like this, because we're talking about non-transitive routing, VPC A can talk to B, A can talk to C, A can talk to D, A can talk to E, A can talk to F, and A can talk to G. But in non-transitive routing, B can talk to A but can't talk to C or to G. B can't talk to C through A. D can't talk to B through A. And here's why. If VPC B gives its routing information to VPC A, and VPC A says VPC C, here's VPC A's routing information, then VPC C will know how to reach VPC A. And if VPC C provides its routing information to VPC A, which gets provided to VPC B, they both know how to reach each other. Life is good. But there's a rule in VPC peering, unless you break the rule, that when VPC B tells VPC A doesn't tell anybody anything. So this means B can reach A, but none of the spokes can reach each other through the central thing. So just like BGP, in order to get around this, we have to fully mesh all of our VPCs. Now, for any of you IBGP people or people that have ever done full mesh WANs before, you know the problem. We get into this mathematical arithmetic issue where the formula is n times n minus 1 divided by 2. So let's think about this. 3 VPCs, this is beautiful. 3 times 3 minus 1, which is 2. So 3 times 2 is 6 divided by 3. 3 VPCs, 3 connections. It's looking beautiful, right? Easy, easy, easy. And this is what it's going to look like. Now, in this environment, VPC-B can reach C, VPC-B can reach A can reach C, and A can be B. So everybody can reach each other because they have a connection to each other. Assuming one of these connections doesn't go down. Now that's fully meshed. So now let's imagine there's 10 of them instead of 3 of them. Well, 10 times 10 minus 1 equals 9. 10 times 9 is 90 divided by 2. Wow, we've got 10 of these things. We've got 45. Uh-oh. Let's pretend we've got more than that. Let's pretend we've got 100 of them. So 100 times 99 equals 9,990 divided by 2. So now all of a sudden we've got 100 VPCs and we've got now 4,950 VPC pairing sessions that we need to do. You can only do 125 VPC pairing sessions on AWS. You're broken, you're done. Okay, so what does that mean? It means you've got to either fully mesh them or have bad communication, or we go back the way that networking did. So about 30 years ago in networking, we had this identical problem with IBGP. IBGP is non-transitive. So we said, oh my God, we're fully meshing our peers. We've got 2,000 routers in our network. 2,000 routers that were fully meshed to everybody. So I'll do it with you. 2,000 divided by, so 2,000 times 1999 equals 3,398,000 divided by 2. So now we've got a certain amount, and now we're dealing with 2 million connections. This is insane. So in IBGP, the Internet Engineering Task Force came up with a great idea. It was called a route reflector. What was a route reflector? A route reflector was something that said, break the rules of non-transitive routing. So what do you think AWS did? They went back to the 30-year-old technology called the BGP route reflector and decided to say, cool, brand new, modern. We're going to call it Cloud Hub. And then they said, okay, well, Cloud Hub only works with VPNs. We're going to create a new Cloud Hub and call it Transit Gateway. Guess what? They're the same thing to we networking people. To the certification people, they're different. To the networking people, they're the same thing. They basically are a way to use a BGP route reflector to bypass the rules of transitive routing. So if you want to break the rules of non-transitive routing, you use Cloud Hub. So Cloud Hub enables you to break the rules of non-transitive routing. So I will show you what Cloud Hub does. So when you use Cloud Hub, like in this situation, this Cloud Hub, what's going on here is doing the following. When Boston sends its information in, Boston's information is not only given to the VPC, but it's allowed now to go to Washington and San Francisco. Because the Cloud Hub says, break the rules, share information. And then when Washington gives its route to Cloud Hub, be it eBGP, because eBGP is transitive versus IBGP is non-transitive, Washington's routes get sent to Boston and San Francisco, and then San Francisco's routes get sent to Washington and San Francisco. So now everybody can talk to everybody. It's party time. They're dancing, they're singing, they're all together. It's good cut times. So we use Cloud Hub or Transit Gateway. Oops, we didn't mean to do that. To break all the rules of, what are we talking about? All the rules of non-transitive. So Cloud Hub lets you create a hub and spoke environment in a transitive routing. Cloud Hub uses nothing else than my favorite routing protocol, BGP. Where do you think it comes from? It's all BGP. So instead of using IBGP, we're using eBGP. And basically what happens is we're using BGP, the routing information is propagated across organizations. And because it's BGP, we can manipulate, we can tune, we can share some routes, all the routes, not other routes, and we've got lots of security. So the VPC, once we do VPC peering, I will have access to everything. Everything. So let's look at this, another example. If you didn't want Cindy to be able to talk to London and you didn't want New York to London, just don't use Cloud Hub and they won't be able to. But if you wanted Sydney to be able to reach a single subnet in New York and someone in London be able to reach a certain subnet in New York, when over BGP, we can limit the routes or do this, or we can use access control lists, firewalls, etc. So keep that in the back of your mind. Now, let's talk about the completely different but identical service called Transit Gateway. So now let's pretend instead of using VPNs, you're using a direct connection or a VPN. And now we use the brand new term called Transit Gateway. What do you think it does? It enables us to connect via eBGP from all these locations and have fully transit routing. Same thing, the name's different. It's slightly different in functionality, but the concept is the same. So now you know a little bit about Cloud Hub, fully meshing your VPC peering, and private link. So all kinds of cool, exciting, and fun stuff. So now let's talk about packet filtering for security. So about 30, 40 years ago, when Cisco came out with their routers, they had a concept called an access control list. An access control list you would use to keep traffic in and out of subnets. Well, okay. AWS said, Cisco, what you did 40 years ago, we love it. We're going to have a network ACL, which is going to do exactly what you guys did 40 years ago. And it's designed to keep unwanted traffic out of your subnets. And a network ACL will allow you to allow or disallow traffic based upon a policy. It's very much like a Cisco extended access list. And then you include the source and destination address, protocol, port number, etc. Now, access control lists are not stateful, so nothing's watching the connection. So if you've got allow web server, if you've got traffic coming into a web server on port 80, traffic with the source port 80 and a destination port of something else must come out of that ACL, so it'll have to be applied in both directions. Now, here's the ugly part of an access control list. The rules are processed in order. So I want you to think about this. Let's pretend you have a child and you've got two parents, and the child's a mischievous child. And the child goes to the mommy and says, Mommy, I want to go out. And mommy says, no. And daddy says, yes. Well, here's the thing. If the child asks daddy first and daddy says, you can go out, and then the child won't even ask mommy because the child's already out playing in the grass, playing in the mud, getting in trouble doing who knows what. So the order matters. Now, the default policy of an access list is deny all traffic. But once a rule is processed, it takes action. So let's be very, very careful. Be very, very, very careful what's going on here. So let's actually look at some of these things. And if you can help me with some more likes, that would be great. So when we're dealing with an access control list, the order matters. And it matters not a little, but it matters a lot. I'll give you an example. Let's think of this character that made this access list. Rule 1, deny everything. Guess what? Everything is already put in the trash before we get to Rule 10. So what this access list needed to be. Rule 10, deny everything. Guess what? Everything's already blocked. It's thrown away by the first rule. It's kind of like the parent that asks the child, or the child that asks the parent. Order matters. So let's talk about how to do it differently. Do we need this deny here? No, a deny is implicit. So how about this? Only allow TCP traffic in to port 80 or web traffic. Only allow port traffic in. Okay, let's change it. Only allow port 443 for SSL traffic. HTTPS traffic. It doesn't matter. But the point is the order matters. If I had to permit any, that good? let's look at this and where they're applied. So an access list protects a subnet. An access list protects a subnet. An access list protects a subnet. Access list protects a subnet. So please remember that. Access list protects subnets. Subnets. Security group protects services. Everybody, say it with me. Security groups protect services or servers. Access list protects subnets. Access list protects subnets. Security groups protect servers and services. Why am I telling you this? You'll see 4 or 5 test questions on this. And if you get asked the test question, which do you need? The answer is you need both. So keep that in the back of your mind. So as you can see here, we've got the network ACL protecting the subnets. And you'll also see we've got a security group highlighted in here protecting the gray. So kind of keep that in the back of your mind. So as we leave here, let's talk. So a security group is just like an access list, but it's applied to a server, for example. And a security group is a stateful firewall. So what is it? A stateful firewall that's placed upon your servers. So let's think about this. If we have a firewall that says, go into the server port 80 and port 443, now what's a stateful firewall doing? Some port 443 traffic crosses the security group. It goes into the server. The server says, yes, I'm responding to you. And it goes back out that same firewall. Guess what? The firewall tracked the connection. It's stateful. So here's my security group. It's a stateful firewall. Traffic is allowed in to the system. It reaches the system and the firewall says, yes, 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 allowed in, allows the traffic to go back. Security groups like firewalls are only configured in one direction. Why? Because these devices are so smart. They know to allow the traffic out in and its return traffic out based upon policy. This is the way all firewalling is done. So a security group protects a service. Now again, everything is denied by default. So security groups only permit allow rules. All non-allow traffic is denied. But unlike an ACL, it's more like a firewall. All rules are evaluated prior to allowing or denying traffic. So let's see what the security groups look like over here in this context. As you can see in the security groups, because I made them blue, they are protecting the server or the virtual machine. Network ACLs are here. So which are we using? Both of them. And that's just part of it. Okay, so we got some really cool fun stuff to talk about, placement groups and all this cool stuff. I don't know how long it's been since our last break. How long has it been, Chris?
It's been about the right amount of time.
Okay, so let's bring in some questions from the group. Sure. And can I explain egress-only internet gateway again? So sure. In an IPv6 environment, if you want your devices to be able to go to the internet to, say, upgrade their operating system and allow their traffic back, you use an egress-only internet gateway. But, so kind of keep that in the back of your mind. It allows you to go out to the internet and allows your traffic back, but it won't allow your systems to be reachable from the internet. So you wouldn't use it if you needed a web server, and it's a great question. Alan, I'm not sure I completely understand your question. VPC peering is non-transitive, so let's pretend we've got 3 routers. This hand, and my head, they're all routers. What non-transitive routing means, if this hand tells my head, who's also a router, I'm not allowed to tell this hand. And therefore, this hand doesn't know how to reach this hand through my head. That's non-transitive routing. Transitive routing would be compiled as this hand tells my brain, this other router, about the route, and then I tell this hand. And then this hand tells my brain about a route, and then this hand. And then these two know how to reach each other. That's transitive routing. So VPCs can share routes via BGP with each other. VPC peering is non-transitive, which means you either must be fully meshed or use something like Cloud Hub or Transit Gateway to allow transitive routing, and you'll be in good shape. Chris? The default for us, the security group, is to deny everything, as all firewalls. A little quiet here with questions. Either I'm doing really good or you guys are getting really shy. So I'm going to wait for a couple more just to be careful. See if there's anything else that popped up in the chat box that I didn't see. You know, when I see this 6 R's, they're kind of silly to me. So let's talk about the reality of them. There's 90% of what we do, which is lift and shift, which is basically rehost. That's mostly what we do. There is some, re-architecting, which is basically you redesign your stuff and move it to the cloud. And there's some refactoring and tuning that we do. And otherwise that, whether you talk about retiring, so pretty much it's either lift and shift, it's either redesign your applications completely to go be cloud native, or it's a combination of both. Things like not using your stuff anymore, or just getting rid of it, or using new services. They call it 6 R's, but they're your main migration things. And you need to be an expert at lift and shifts. And you need to be an expert at lift and shift plus tinker. And you need to be an expert at refactoring, because that's all we do as architects. What do I mean by services? So when we talk about services, so let's say you have a web server that's an Apache web server that is open on port 80 and port 43. That's the service it's offering. It's offering web services. We've got another server that's open on port 20 and port 21 that's doing FTP services. We've got another server that's responding and terminating at SSL connections via the OpenSSH. That's another service. So I meant services as in the context. Well, actually, that's a service in general, but that's not what I meant. I meant a security group being used for a cloud service. So it could be used for a virtual machine. You could put a security group on a load balancer. It's kind of a firewall that gives you the ability to protect any type of an AWS offering, not just virtual machines. That's what I meant by services. Good question. Calpsoni, I have spent more than 10,000 hours learning and working on BGP. To really talk briefly about BGP would be 30 to 40,000 pages to really give you something complete. We actually did a 3-hour BGP webinar, and we've provided the links to that. We also read a BGP article, which we provided the links for. And I'm happy to do another 3 to 5 hour BGP, tutorial seminar, and I'd be thrilled to do it. But there's no way we could cover it now, because truthfully, to cover BGP properly would take more than the AWS Certified Solution Architect Associate and Professional. And we still would barely be scratching the surface of BGP, to be fair. Ayuk's got a great question. When do you use Cloud Hub and when do you use Transit Gateway? Well, if you're using VPNs, you use Cloud Hub. If you're using VPNs and private lines, you use Transit Gateway. So Transit Gateway is probably the best choice to use anything, because if it matters, you're going to use a private line out of VPN. So you'd be using Transit Gateway. But Cloud Hub is good for VPN access. Really rock solid question. Cecil, if you only use an ACL and only a security group, you're going to be hacked. So you're going to need, realistically, to secure your systems, next generation firewalls, intrusion detection, intrusion prevention systems, and you're going to need firewall. And after that, you'll need an access control list. After that, you'll need a security group. On your server, you're going to want to put a second firewall, like a host-based firewall. You're going to want to disable unnecessary services on there. You're going to put some anti-malware protection on there. You're going to do a lot of patching and hardening. You're going to be encrypting your data on that storage. You're going to be using an IAM policy. And Cecil, I still haven't even scratched the surface of security. So not only do you need both, you're going to need about 10 times more to make your system secure. Lift and shift, Georgetta, is the majority of what people do. And what is it? I've got 10,000 virtual machines in the data center. All I do is just bring those virtual machines to the cloud, which is basically taking it off my physical data center and moving it to the cloud, which is nothing more than a logical data center. So poof, poof. You don't need to know anything of cloud services at all to do it. All you need to know is network and data center stuff. So If you know what a virtual machine is in the network and data center, you know how to bring it to the cloud. Okay, Srineth, unfortunately, I don't even know what you're trying to ask here. BGP is called Border Gateway Protocol. It is an exterior gateway protocol, but it's a standard that routers use. The rest of your thing, I don't even know where to begin with it. An access control list is a stateless packet filter, just like an access control list on a router that keeps traffic out of a subnet. A security group is a stateful firewall that keeps traffic out of a server. Okay, so are there hardened AMIs? Not good enough. So if you want a hardened AMI, what you're really going to be doing is when we protect our network, we're going to talk to you about the AWS native security services. And I'm going to tell you in reality, you're not going to use them. You're going to be using industrial grade enterprise security services, which we're going to get from the marketplace. I have zero use for AWS security services because I do multi-cloud for every customer. So the security services, so one of the reasons we say not to make a bastion host is the following reason. Somebody makes a computer and they try and harden it themselves. And let me tell you, it's hacked into immediately. Now, by comparison, if it really mattered to you, you could go to the marketplace. And let's say you got a firewall that was made by Palo Alto. Palo Alto would harden that operating system and they'd install their firewall system. They'd lock it down. They'd be removing half of the protocols, ports that are open. They'd patch the kernel. They'd do all those things. That is a truly, truly, truly hardened system. And that is a very special system. And yes, there are some hardened things, but I wouldn't consider any of the hardened things truly hardened. If I need something hardened, I'm getting it from the marketplace. Or I'm going to hire some very good security professionals to help me do it. Srineth, I still unfortunately don't understand your question. As you're explaining on BGP, how far is it using cloud architecture? If you're asking,
is it inherently part of cloud architecture?
It is one of the most critical parts of cloud architecture that if you don't know, you'll never be able to design a system and the systems will never work. So it is critical, critical, critical. And we spend a lot of time on that in class, in our career development program. Alan, we do this in every single class. That's exactly what we do. That's the difference between, how do you create a new social media giant? How do you create the Netflix of the future? How do you create a next generation bank? How do you make a healthcare system operate? How do you build a global retailer? These are the things that we do in our cloud architect career development program. See, that's architecture training. This is certification training. We do certification for free, but how do you get a job? That's what we do in our cloud architect career development program. So if you want to vote on the next boot camp, please vote on it. The link is in the description below for the voting page. And before we get back to the content, let's get back to, if you give me one more hashtag cloud hired, because that's what we do. We get everybody cloud hired. So give me a cloud hired. And then we'll get back to the free and comprehensive training. And if you've not liked, commented, or subscribed, please do so. It signals the algorithm that we're doing something good, and it brings more people to us so we can help more people with free training. And that's really something that we love doing around here. And the place to vote is not actually in this chat box. It's actually the link in the description below. There's a web page that we've got a form for you.
It is in the chat box.
Oh, it is in the chat box? Even better. Okay. So it's in the chat box. Even better. Because you said link in the description below on the top.
It says description and chat box.
Oh, okay. There we go. So fair point. Okay, getting back to this kind of stuff. Let's talk about network performance optimizations on AWS. And in this section, we're going to talk about some fun stuff. We're going to talk about placement groups. We'll talk about something called single root IO virtualization. I hate these technical terms. We'll talk about something called the elastic fabric adapter, who makes these things up, who can dream them up. We'll talk about Route 53 or DNS, and then we'll talk about load balancers, which are some of my favorite, coolest devices, even though they're not considered to be networking devices from networking professionals. And the first thing we're going to talk about is placement groups. Now, there are times when we need to build low latency environments. Now, if you really need a low latency environment, don't use the cloud. Stick it in the data center and you're good to go. But if you're doing things that require lower latency in the cloud, and all your stuff and your users are coming in from the cloud, you can do the following. You can put your stuff closer together. So here's what we're talking about. When we get to the cloud, we're talking about something that's 1,000 miles away or 1,500 miles away, which is why we've got all this latency. Now, what if we have a high-performance computing cluster where we're trying to get into the sub-millisecond range, even in the nanosecond range? And in order to do that, we can't have a cable that's 1,000 miles. In fact, we can't have a cable that's 1,000 miles. We're trying to cut our cables to basically 5 feet. And we're going to be using fiber optic cables where the speed of light is 186,000 miles a second. So we're talking fast stuff, almost 300,000 kilometers a second. So what we do is we put our instances or our computers close together. By putting our systems really close together, there's less latency between our systems. Now, there's a disadvantage to that. If I put all my systems in the same rack and there's a power failure on that rack, all my systems go down. So, placement groups are a way to improve your performance by putting stuff real close to each other to minimize latency. But the trade-off is a reduced level of availability. So we're going to talk about the types of ways you can actually place your systems. And they are as follows. We're going to talk about cluster placement groups first. And here's what a cluster placement group is. And I've done this in my career. And it's also insanity too. But I've done it in my career for banks. Effectively, here's what it's like. You take a rack, and on the same rack, you put all your servers. And sometimes they're even in the same server, if it's a virtualization, and the same switch. And what happens is, because your systems are all in the same rack, the latency between your servers is blisteringly fast. So say you're working with a banking application where a nanosecond matters, you'll create 2 cluster placement groups. Now, if it matters, it's not going to be in the cloud. It's going to be in the data center. But let's presume we're doing it on the cloud for right now. A clustered placement group looks just like this. It basically looks like we've took all our stuff, stuck it all in one building and all in one rack. Woohoo! Problem in the building, you got a problem. Problem in the switch that they're all plugged into, you got a problem. Problem with the power distribution unit in the rack, you've got a problem. So as you can see, blazingly fast performance, really ugly from an availability perspective. So if you're doing a customer placement group, make sure you have 2 of them. And this is really risky stuff. I've done it for banks, and here's what it looked like. Rack 1, rack 2, 5-foot cable going in, fiber optic cable going into 2 different things, side by side. And we're talking about the biggest, baddest servers running on bare metal, running on NVMe RAID arrays. So if it matters that much, you probably shouldn't be on the cloud. Just keep that in your mind. So what if you need good performance, but you don't want to be insane? What if you want a little bit of protection from failover? This is where we get into the partition placement group. And it gets a little better. And in this particular case, what do? We can stick our stuff across multiple racks in the same data center. So now we're protected against the power failure in a rack. We're protected against the network switch failure. And we're protected against the single server failure if all the things are. So lower, much higher latency in this, because we're now going across a whole building versus a couple of feet, but we're not crazy. So what's it look like? It looks like this. You're taking up a couple racks in the same data center. So this is really what we're talking about. This is real data center stuff that we do. It looks like this. It's pretty standard. And then let's say you wanted to have lower latency, but you wanted to have more redundancy. This gets us into something called the spread placement group, and it looks like this. Here's what a spread placement group is, everyone. In a spread placement group, basically you put your stuff across multiple availability zones, for example, and how that works. So now you're spread across buildings or data centers, lower performance, but guess what? More reliable. So clustered placement groups, all in the same rack. Partition placement groups, all in the same data center. Spread placement groups spread across data centers. Wait, spread across data centers, greater availability, lower performance. Spread across the data center, still pretty darn fast, but good availability. All in the same rack, blazingly fast. But oh well, from a redundancy perspective, you've got problems. So let's talk about the next thing. So I don't know how many of you have worked with virtualization in the past, but the cloud is all virtualization. We take a physical thing, we virtualize it, and now it's a cloud, okay? So it's now the cloud. Now, here's the thing. When we virtualize stuff, we kill the performance. So you work on a bare metal server, and then you work on the virtual server, you get 10% better performance on the real machine. Why? Because the real machine's physical hardware. The hypervisors add overhead. Now, in our virtual machines, we have two options. We have physical cards and we have virtual cards. Now, in a standard virtual machine, you get a fake GPU, a virtual one, a fake network card, a fake hard drive, a fake everything. And what do you think the performance of a software-generated network card is? Or a software-generated video card? Not good at all. So maybe you're dealing with a system for a video editor that's online and he or she needs a GPU. Maybe you're setting up a server and you need to do some machine learning and you need physical GPUs, high-performance GPUs, not virtual GPUs. Well, somehow on the server end, you need to push that physical card into the virtual machine. So it's a technology called PCI pass-through. So you've got a PCIe network card, you pass that through into the virtual machine. Now you've got performance. Now you've got a GPU and you pass it into a virtual machine, and now you've got a machine learning virtual machine. So the technology we're talking through right now is PCIe pass-through, because we're taking a PCIe card and we're passing it through into the virtual machine through the hypervisor. Now, when you're dealing with AWS, they give you two very good options for better networking. They use what VMware enabled and claimed the term single root I/O virtualization. Guess what? It's a physical network card in your virtual machine. That's all it is. AWS calls it enhanced networking. VMware calls it single root I/O virtualization. All it is a physical network card in your virtual machine. Now you know what it is. Now, when we're dealing with virtual cards, we're dealing with virtual hardware, and we're dealing with virtual drivers. And because virtual network performance isn't good, AWS has been working on a very high-performance network interface, a logical one. And it's called the Virtual Fabric Adapter. And AWS says at some point it can go up to 400 gigabit a second. The performance is nowhere close to that now, but it is much better than a fake card and a logical driver. So single root I/O virtualization, really good performance. Virtual Fabric Adapter, really good performance. Standard network performance in a virtual machine, very mediocre. Okay, so now we are going to get into DNS stuff, DNS. And what is DNS? DNS is basically simple, mapping a name to an IP address. And here's the reason why. Let me get a terminal window so I can actually answer this. Bear with me a second. I think it's iTurn now. Okay, so if I do it, second. Okay, so here's the thing. If you're on a Windows computer and you type NS lookup www.gocloudcareers.com, here's what you're going to see. You'll find your DNS servers, and then you're going to find the IP address of my website, which is actually hosted in two places. So you'll see two web servers, and you'll see that the address of the server is 192.0.78.137. That's the IP address of the Go Cloud Careers web server. Now, if you remembered and put in your browser 192.0.78.137 with the port number, guess what would happen? It would take you to Go Cloud Careers. Now, I don't know about you, but I can't remember 192.1.0.78.137. And I can't remember, I don't know Chris's phone number, and I talk to him every day. It's programmed inside of my computer. I do know how to go to the Amazon website, though. I do know how to go to the Cisco website. I know how to go to the Go Cloud Careers website because I can remember those names. So what is DNS, or the domain name system? It's simply a means to map a name to an IP address. Very simply. www.gocloudcareers.com. Map that to 192.0.78.137. www.cindythecat.com. A whole lot easier to remember than some straggling numbers out there. So kind of keep that in the back of your mind. So, we can look at it over here. I'll give you another example of what it looks like. Here we've got a user that goes www.amazon.com. The browser does an NS lookup from the DNS server. The DNS server gives it the IP address, and then the computer reaches out to it via its IP address. In case you don't want to have fun on your computer and you want to type up, you don't want to type NS lookup, here I did it for you. NS lookup, www.amazon.com. The first two things are my DNS addresses, DNS server addresses, and then here's what you see. This is actually the address. This 13.35.116.114. Now this is actually the DNS name. This DAA4. Now that's that's the real address. So what happened is AWS, they basically took a CNAME record and they mapped Amazon.com, which is comfortable and convenient, to this ugly content delivery network thing, and that's how it works. So DNS is cool and exciting and fun. So what goes into this? Well, domain names are basically going to be mapped out into three separate sections. It'll be the host name, the domain name, and the top level domain. So the host name, www. The domain name, Go Cloud Careers. The top level domain.com. And now you know what that is. So the domain name is 3. Now it could also have been mike.ec2.gocloudcareers.com, where mike.ec2 would be the host name. Or MikeEC2, let's remove that dot because it's going to break something. So MikeEC2.gocloudcareers.com would also work. It's a fully qualified domain name. So when you've got your host name, domain name, and top level domain all together, what's it called? A fully qualified domain name. So what is DNS? It's a server record storage environment that translates names to addresses. Well, okay. Well, if you're going to do this, you probably need a standard set of instructions, right? Yeah, you do. So the way this is going to work is going to be as follows. DNS is going to record something called, or have something called a zone file. And the zone file is going to be a particular set of directions that are inside of the DNS servers. These records are going to be in a particular format called DNS syntax, which is really a text file that's going to explain everything, how the server carries out its actions. Now, there'll be something called the time to live. The time to live is how long the server will keep the information before refreshing it. So think about it. If it got a time to live of a year, the server will only have to speak once a year. Now, if you make a change, it'll take a year for people to know about it. So the TTL. Now, TTL is normally measured in seconds, but it can configure otherwise. And there is a huge number of DNS records that are out there. There's only some that you need to know, and we'll talk about the ones that you need to know. Now, when we're dealing with AWS, their implementation of DNS is called Route 53. Route 53 is highly scalable and also uses something called unicast. So if you went to my NS lookup of www.something.com, here we go. go back to this slide. I want you to see something. So when we go back here, you can see my DNS servers. Now, these are Google's DNS servers that I'm using, 8.8.8.8. And note, there's two 8.8.8.8. Okay, this is ugly. This is something called Anycast. So Cindy the cat, who's sitting in Florida, and the beautiful Noni the cat, who's sitting in Asheville, North Carolina. Now, both of them are having a phone conversation. Now, Noni the cat and Cindy the cat decide that they're going to be DNS servers. And they decided that they're going to use the same IP address. And all of the IP people like me said, okay, no, you can't have the same IP address in two places. You've got an IP overlap. And Cindy the cat and Noni the cat have an IQ of 180. They're both super geniuses. And when the two of them are talking, they say, hey, wait, let's use the same IP address. And let's exchange information between us. And here's what's going to happen. I go to www.gocloudcareers. And as soon as I do this, my PC does a DNS lookup. Now, when my PC does a DNS lookup, it looks for the address of the DNS server. And it sees 8.8.8.8, which I don't have a route in my routing table to 8.8.8.8. So I go to my default gateway. Now, my default gateway goes to my ISP, and my ISP sends me to the closest 8.8.8.8, which is my cat Cindy's, which is sitting in Port St. Lucie, Florida. Now, if for some reason Cindy takes a nap, and she naps about 16 hours a day, and Cindy's sleeping, and I go to the server at www.8.8.8.8, guess what happens? Cindy's sleeping. So she's sleeping. She does not answering the call. She doesn't respond. So then I get routed to Noni the cat's web server that's in Asheville, North Carolina. And Noni responds, and now Noni is there. So what Anycast is, we use the same IP address in two places, and we only intend on reaching the closest one to us. And by doing that, we create a level of redundancy and availability that's fantastic. So AWS uses Anycast, which we love. It's got low latency, high availability supports, and it supports health checks, which we'll talk about soon. Now, when we're talking about DNS, there's several types of DNS records that matter. We're going to cover some of them. Here's a list of some that you should know, or at least the majority of it. But this A record, this AAA record, this CNAME record, this MX record, and this SOA record, you must know. So we're going to cover them now. An A record is the most fundamental DNS service. It maps a name to an IP address. So www.gocloudcareers gets mapped to 192.0.78.137. That's an A record. Now, let's assume I was using IPv6. Well, that would be an AAA record, same thing. So A record, beautifully simple, maps a name to an IP address. Now, after this, what's next on the list? What are we talking about? What's next on the list is something called the CNAME record. So what is a CNAME record? So when we went to, let's go back to this CloudFront thing. Let me show this to you again. On the CloudFront thing, this is actually the DNS address of Amazon.com. This Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.com. That is actually the DNS address of the Amazon website. But would anybody be able to remember that? I can't. And since I'll never remember Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net, I'll never remember it. But what can I remember? www.amazon.com. So Amazon mapped www.amazon.com to Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.com, which is also the IP address of 13.35.116.114. So now you know we mapped the name like Amazon to that ugly thing. That is called a CNAME record. Now we're next going to talk about an NS record, which is a name server record. This tells you who or what is your DNS server. Okay, so When we saw that Google was my 8.8.8, that's because of the name server records. Now let's talk to this. So the next thing we'll talk about is an MX record. Well, some people like to receive email. So if you want to receive email, you will have to create an MX or a mail exchange record, which specifies which mail servers can accept mail for your domain. Now, after this, we've got something called the start of authority record, and this identifies the primary name server for the domain, the responsible party for the domain, and the timestamp change that anytime anything changes. So, and also it includes the number of seconds before the zone should be refreshed. So, here's what we're going to do. I think now is a good time to take a break, answer some questions, and then we're going to start talking about the cool routing policies in DNS, and it is really cool. So let's see if we have any questions that we need to address first. Can I please more elaborate what is private cloud and how who implement it and how number of customers prefer it? So most customers have a private cloud that's connected to a public cloud. That's called a hybrid cloud. And in many cases, it's cheaper to run it in the data center than it actually is in the cloud. And in other cases, it's cheaper in the cloud than the data center. And it's based upon the capacity, the use case, and the patterns of usage and the type of traffic. For example, if you had to do machine learning 24 hours a day, 7 days a week, 365 days a year, you could buy a server from NVIDIA for 100 grand, or you could pay 100 grand for that server every month in AWS for the next 3 years, or 200 grand for that same server. So in some cases, it's much cheaper to be on the data center. Now, if I only need to use that server for 15 minutes, 30 times during the year, it's a whole lot cheaper to do it in the cloud. So part of being an architect is being able to analyze the customer's business, analyze their expenses, analyzing their sales, their revenue, their personnel, and then figure out what kind of technology can go improve that business. And that's what we do as architects. So this is the kind of thing we teach in our Cloud Architect Career Development Program. Who implements it? Well, it's like everything else. A cloud architect designs the private cloud and a cloud engineer builds it. Architects are system designers. So you'll have your network architecture, enterprise architecture, cloud architects designing the cloud solution, and you'll have your cloud engineers and people building it. Good question. AAA was for IPv6. I don't know what you mean by C list. Oh, maybe mean scene name. A scene name maps one thing to another, very similar to an alias record, but slightly different. Good question. N tier. Hold on one second. Oh, okay. So, yeah. So, realistically speaking, the only people that use these kind of N-tier things are more TOGAF, and nobody knows what you mean. These are these theoretical things which map services to services, and it's really more about application stuff. As architects, we're dealing with the physical content of what we're doing. So, what do the routers look like? What do the load balancers look like? What do the IP addressing schemes? Where are your virtual machines? Where are your containers? Where's the firewalls, et cetera, et cetera, et cetera. So that's what we're typically talking about in what we do. When we're dealing with N tiers and that, we're talking in the application world, and it's not really the cloud architect world or the enterprise architect world for the most part. And when it does get into the enterprise world, architect world, that's the stuff we have to translate to our customers because they don't know what it means. So I don't make N-tier architecture diagrams ever and have not in 25 years for that reason. You're going all down in these theoretical things that I don't use with customers because my customers don't understand it. I built a career taking TOGAF things that the TOGAF team would develop that the customers would say, get that stuff away from me. And I translated it into things they understood. Now, Slade, this is something different. This is where we're talking about a 3-tier web architecture. And what is a multi-tier web architecture? That's based upon What we're talking about is decoupling our architecture. So it used to be we'd have the LAMP stack all in a single server. Linux, Apache, MySQL, PHP, all in a single server. So we'd have the application logic, the web page, and the database in a server. And then what we decided over years was that didn't scale so well, because now we've got one server. And what if we could put the web servers on their own servers and load balance them with a load balancer, and then have a set of application servers which we could load balance as necessary. And then we had a set of databases which we could build out or scale in and out as we needed. So by modularizing our environments, we can decouple them and make them scale. So yeah, that's definitely with regards to everything. IUC, there's very subtle differences between the scene name and the alias record. And each time you're really going to look at that up. But for the most part, I use a scene name to map one ugly domain to another domain. But an alias record you can use in some of the same places. Great question, IUC. And smart, because they're pretty much the same thing. Good job. Well, a lift and shift isn't PaaS or SaaS. Lift and shift is all infrastructure as a service, which is 90% of it. Lift and shift, you take a virtual machine in the data center and you move it to a virtual machine in the cloud. Platform as a service and software as a service, they're very cloud native things, but here's the thing we need to remember. Once we start refocusing or reconfiguring our applications to platform as a service, if the cloud provider raises our rates, we're stuck and we got to go spend a fortune to get out of the cloud. If the cloud provider kicks us out, like AWS kicked out a customer a year ago because they didn't like their business model, and the company basically was shut down as soon as they were kicked out. So platform as a service means refactor your applications, and it locks you into a single cloud for the most part. So most of the multi-cloud stuff is lift and shift. And in most cases, it's a better solution. Does it matter who you buy your domains from? No. We're going to talk about the difference between a registrar and a registrant. And it doesn't matter where you get your domains as long as they allow for domain and zone transfers. Smart question there. Real good one. I love these things. Okay. And I'm not big on theory, and that's kind of clear. And the reason I'm not so big on theory is, as an architect, we've got to talk to our customers. We've got to sell it to our customers. And our customers don't like theory and fluff and pretty pictures. They like something they can truly understand. So simple is really something we're really concerned about with everything that we do. It's all about the elegance. Because remember, we got to troubleshoot it when it breaks, or somebody does. So now that we're talking on, and actually we ended a break, so you can give me a cloud hired, like Chalice says, cloud hired for everyone. So let's talk about some of the routing policies. With AWS, you got a lot of routing policies. So we can do simple routing, weighted routing, latency-based routing, failover routing policies, geolocation routing policies, multi-value answer routing, and geo-proximity. So we'll talk about how, where, and why. Let's talk about simple routing. I love simple routing. It maps www.gocloudcareers to a single IP address. Real simple, real elegant. Most basic thing, name, IP address. Poof, you're done. Life is good. So we have that. Now, that's what I use for my business because I don't have anything complicated. Don't need it. Let's talk about weighted routing because this is where it gets really cool. So with weighted routing, we can say send 10% here and 90% here, or 50% here and 50% here. So let's think of a multi-cloud architecture. Send 50% to your traffic to the AWS cloud and 50% to the Google cloud. Done. Now you've got multi-cloud. You're solid. Love that. But guess where else weighted routing is cool? You got your data center, it's your primary, and you want to offload 20% to the cloud. Send 80% to the stuff you've already bought that's paid for, and only 20% to the cloud. Where else does it get even cooler? Because it gets cooler too. Your team decides to write some new code and a new website. Do you want to roll out your new website to 1 billion users on the first day? What about bugs? What about problems? So maybe you deploy a new application. It's called like a blue-green deployment in the DevOps world. And you send 10% to the new website or new application and the other 90% to everything else. Now you can see if the new application works with your friendly users. And if it works, great. And if not, get rid of it. Like that. So let's talk about some latency-based routing. Well, let's say you want the lowest latency. What is latency-based routing? Well, when you start, it checks your source IP address and it says, the fastest server for you is in Tokyo, New Zealand, Brisbane, Australia, Dubai, UAE, Lagos, Nigeria, Cape Town, South Africa. It doesn't matter. You see where we're coming from? Latency-based routing sends you to the server with the lowest latency for the best user experience. How about another routing policy? This is a simple one, failover. Send all your stuff to your data center. If your data center fails, send it over to the cloud. That's failover routing. Makes sense, right? Let's talk about geolocation, and geolocation is cool. So geolocation enables you to route someone based upon their source IP address. So let's think about this. Let's take a country like Cameroon. Cameroon has two primary languages. There's a French side and an English side. There's other stuff, but let's just say the French and English. Wouldn't it be cool if on the French side, the user goes to a website and they get sent a French web page, but a user on the English side of Cameroon, somebody looks at their web, they look at their source IP address and poof, they go to the English one? Look about the Middle East. We can have some people going to an English website, an Arabic website, a Farsi website, a Hebrew website, all based upon geography. So I'm loving this, loving this, loving this. Geolocation is great. For a guy like me that works in all these countries, having people going to the right place is awesome. And yes, we love Cameroon. We've got 200 Cameroonian students, and we are a big sponsor of the Cloud Heroes Africa project, where 50 of my students help volunteer with me to help make that mission possible because we love it so much. So super happy to see you here at M, but we love everybody and we do what we can to help. But that's geolocation routing policy. Now, this next one seemed kind of dumb to me because I don't like random, and it's called multi-value answer. And it's kind of like flipping a coin. Okay, I'm going to go to this server, and it's pure random. I don't like random. I like knowing where stuff's going. You know, I don't build my career by just throwing a whole bunch of stuff on the ground and hoping it comes. I architect my career. So I don't do random anything whenever I have to, except for random backoff exponential use cases in networking. So, you know, that's multi-value. And the last kind we'll talk about is geo-proximity. And this is a bit of an ugly one. What happens is AWS will let you create a map, and you can shrink these regions 1 or 2 with something called bias. And when you do this, what's going to happen is it's going to let you send your traffic and prioritize where it goes. So that's all that we're talking about. So when we're talking about DNS, and we're talking about a routing policy like failover, or any of these things, we need to make sure that it's there. So let's say we've got www.gocloudcareers in 2 different locations. Okay, so let's on 2 different web servers. So let's say we have GoCloud Careers that are literally sitting in my private OpenStack cloud, and let's say that GoCloud Careers is also hosting it in the AWS, which even though we didn't use them, we ended up using them anyway because our hosting provider uses AWS. So let's say we're headquartered in here. Now, if I want to send half of my traffic to my data center and half of my traffic to AWS, I use a DNS weighted traffic policy that says half to Mike's data center, half to AWS. Okay, so great, right? Now, if 50% of the traffic is going to my data center and my data center is not there, and 50% of the traffic is going to AWS and they're there, all the traffic destined to me is dropped, and only half of my users are getting websites. So do any of you think it's a good idea to have half of your users access your systems? No. So how does DNS know to send it to you versus somebody else? How does it detect failover? It uses my favorite thing called a health check. And of course, a medical professional like me would love a health check. Why? Because I like checking people's health. So let's talk about Route 53 health checks. Here's what it is. You got the DNS server. So you got Mike's Cloud and you got the AWS Cloud. Mike's Cloud, are you there? Yes, I'm here. AWS Cloud, are you there? AWS says, yes, I'm here. Now, a couple of seconds later, Mike's Cloud, are you there? And I say, yes, I'm here. And DNS says, thank you, Mike. And then it says, AWS, are you here? And AWS says, we are live and well and happy. And this is going to go on. And as long as I'm up and AWS is up, we're going to load share. Now, out of nowhere, Mike, are you there? Yes. AWS, are you there? No response. Mike, are you there? Yeah, me and my OpenStack Cloud are here. AWS, are you there? No response. Mike, are you there? Hey, I'm here. All's good. AWS, are you there? No response. Now what's going to happen is our DNS server is going to say, Mike's healthy. AWS is dead. It doesn't exist. Now send all traffic to Mike. And we'll see this in DNS. We'll see this in other environments. Hey, are you there? Yes, I'm here. Hey, are you there? Yes, I'm here. Hey, are you there? Yes, I'm here. Hey, are you there? Nothing. Now this thing gets removed from the location. It gets marked as unhealthy and removed. So when something fails a health check, the test question answer is it gets marked as unhealthy and not used. So keep that in the back of your mind. Are you there? Yes, I'm here. All good to go. Are you here? No response. Removed. Typically, you have to miss 3 to 4 health checks before the thing determines you're done. Okay, so we've got let's see, 1, 2, 3, 4, 5, 6, 7. How are we all? We all motivated, everybody? Because if you are, I got a load balancer section that I can spend some time on. And if you want, I can answer questions. So what do you guys want? I think if we go on and do load balancers, we probably don't need to work on Saturday to get through this. So if you guys got 20 more minutes and you let me know. If you guys want me to answer questions, let me know. Unmag is motivated. Unmag was one of my students and he's cloud hard and we're super proud of Unmag. Chow says, I love load balancers. Brian McCool says load balancers. Woohoo, here to win motivated. Let's talk load balancers and have Saturday off, or at least try to have Saturday off. Load balancers are awesome. So let's get you guys, since you're all motivated, let's do more training. You're here willing to go on. I'm here willing to go on. So a load balancer. I love load balancers. Do you know why I love load balancers? Load balancers improve availability and performance by removing single points of failure. Load balancers are the world's coolest devices. They make your systems more resilient, more available, and perform better. Love load balancers. And exactly what is it? A load balancer is a device that distributes network or application traffic. Load balancers help greatly with scalability from going from one server to 1,000 by load sharing. Load balancers enable you to scale out by meaning add more servers. And load balancers remove single points of failure. Here, I got one server. It dies. Guess what? Everybody's died. Okay, right? So, and then next. So you've got 10 phones. You combine the formats, you get better performance. So no single points of failure. The phone dies. Guess what? Another one picks up the load because it's load balanced. Now, when we deal with load balancers, we're going to talk load balancers in general. And the reason we're going to talk about load balancers, I want you to understand how they work on AWS, Azure, the data center, Google. It doesn't matter. They all are the same. We have load balancers that work at layer 4 called network load balancers. And we have load balancers that work at layer 7 called application load balancers. That's it. Now, when we're dealing with AWS, of course, they have to stick the word elastic in front of everything. So with elastic, what we're talking about is strip the word elastic, and then you know what it is. It's a load balancer. Azure calls it a load balancer. Google calls it a cloud load balancer. It's just a load balancer. F5 makes load balancers. So AWS calls it an elastic load balancer, and what it does is a load balancer distributes traffic to multiple targets: web servers, firewalls, EC2 instances, what have you. And AWS elastic load balancers are auto-scaling, and they're big and powerful. The functionality is acceptable. Elastic load balancers can spread your load across availability loads, and they can support health checks, and they can terminate SSL connections. So we love terminating SSL connections on the load balancer. Why? If it's terminated on the load balancer, it's not on the web server, so less work on the web servers, more scalability. Excellent, excellent, excellent. And load balancers share the load with things. And how do you think a load balancer determines if a server is available or not? Via a health check. And I'll do my Are You There health check demo, which apparently I'm insta-famous for good or bad, I don't know. So let's talk about network load balancers first. And the reason we're going to talk about network load balancers first is I love them. Why do I love network load balancers? I'm a network architect, so I like all things network. So a network load balancer is a device. It's normally a physical device. In the cloud, it's a virtual device. And the network load balancer is a device that basically looks at the source, destination, protocol, and port number. Poof, and it sends it. So TCP source 192.168.1.1 going to 2.3.4.5. Poof. So a network load balancer does things on the TCP header, UDP header, ICMP header. Now, because of this, the network load balancer is watching the connection the whole time. It's a network thing. It's stateful, and it is fast. Network load balancers are used when you need speed. Load balance between firewalls, network load balancers. Load balance between 120 core servers, network load balancers. When you need speed, you want a network load balancer. And why is a network load balancer so fast? Well, because it's kind of dumb. It comes in source, destination, port, protocol, and it goes through. So I'm going to ask you this question. If you had to add 2 and 2, how fast can you do it? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Easy, right? It's just 2 plus 2. Now, calculate a derivative in your head. Well, assuming you could do it in your head, well, you're not going to do it in 30 seconds. It's going to take you minutes. So network load balancer, really dumb. 2 plus 2 plus 2 plus 2 plus 2. Fast, millions of transactions per second. Application load balancer, which we're going to get to next. Really smart device, going to look into an HTTPS header. Oh my God. That's like doing derivatives. Slow, slow, slow. So network load balancer, fast, fast, fast. Application load balancer, smart, smart, smart. So sometimes you need both. So when we're talking about load balancers, I want you to understand how they work and what they look like. So what it's going to look like is something like this. Here we've got multiple users that want to attach something. We've got a network load balancer that's load balancing between web servers in 2 different availability zones. So availability load servers here, servers here. Now, if this availability zone goes away, guess what? It doesn't matter, because the load balancer will determine that these girls are dead, and it will shift all the traffic here. Now, if everything's up and availability zone A goes away, the traffic will be shifted to availability zone B. So you can see the load balancer providing better performance by sharing the load, but you can also see that the load balancer is also providing high availability services simultaneously. So we love that. So since we talked about network load balancers, which is my favorite because they're fast, 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 let's talk about application load balancers, which are smart, smart, smart. So application load balancers work at the application layer, or layer 7 of the OSI model. And this is very different. We're looking at that. They're looking at the path provided in the URL, elements in the HTTPS header, the HTTP method-based routing, push, get, that kind of thing, and can route based on source address. So application load balancer, smart, smart, smart. Those derivatives are calculated a lot less slow, a lot less fast than the 2 plus 2 plus 2 plus 2. So kind of keep that in your mind. So application load balancers are beautiful for load balancing HTTP or HTTPS traffic, microservices, container-based applications. So it's for stuff that you need intelligence and less speed and performance. And here's what it's going to look like at the application layer program. So, and why not? We'll get your question in a few minutes. But our career development program assumes you have no background, and we get everybody hired assuming they have no background. And our students get hired every day, and we can talk about that later. But what we have here is we have the application load balancer. And what you can see is it's listening and looking to some very, very detail-oriented things. Very detail-oriented things. And the load balancer will send to this target, and this target. So really, that's all we're talking about. Now, they're being phased out of AWS. They have something called a classic load balancer. Guess what a classic load balancer is? It's a load balancer. You know what? It works identical to any other load balancer in that it's either where they have a network version and an application version. That's it. Same damn darn thing with a different name. Apologies there. Now, when we're dealing with load balancers, here's what we're talking about. Normally, people think of external load balancers. What's an external load balancer? A load balancer facing the internet. Okay, it's an external load balancer. Why? It's facing the external world. Now, there's also a such thing called an internal load balancer. An internal load balancer is used to load balance systems that have private addresses inside your systems. Say maybe an HR application or something like that. Now, when we talk about elastic load balancers, we got to go over the terminology and the jargon. There's something called a listener. And a listener is really a process that waits for TCP connection requests. Application load balancers look for HTTP, HTTPS requests and port numbers 1 to 65535. Where your network load balancer is going to look at TCP, UDP, TCP, UDP on the same ports. Now, a listener for the application, listening on everything. Listener for the network, just listening on network ports. That's it. Now, where does the load balancer send this traffic? To the server. What's that called? It's called the target. So the target can be a server or an IP address. Now, if the server is an IP address, the target's an IP address, it must be a private IP address or a shared IP address. And what's that? So what we're really talking about here is as follows. We're talking about something in the RFC 19 address space. So your private address can be the 10. Anything from the 10/8 range, the 172.16/12 range, the 192.168/16 range, or this new shared address space, which is 100.64.0.0/10. So we can talk about that. So listeners, what the load balancer listens for, and the targets where it sends it. Now, what if you wanted to create a target group? What's a target group? It's a collection of targets. So Noni the cat's 10 web servers, that's what we're talking about. It's a target group. Send it to the group of Noni's web servers. And the last thing we'll talk about are sticky sessions. So a sticky session is used on application load balancers to keep. So what happens is on a network load balancer, let's say you got 10 servers. The network load balancer sends it to server 1. Traffic goes to server 1, then it sends it to server 2, then it sends it to server 3. Now on a network load balancer, because what we're looking at is the application flow, everything works great. So if we're dealing with an application protocol that's going to be looking in a header, well, that stuff not something a load balancer can remember. So, excuse me. Well, this is because I have a cat that sleeps on my head or my chest, and I'm highly allergic to her, but I love her, so I sneeze a lot. But that's neither here nor there. So the sticky session is if you want to keep your systems all on the same server, we can actually add a cookie to the load balancer. So I want to go through this one more time. The load balancers listen on something called the listener, and they distribute their traffic to a target. Now, if we want to take multiple targets and group them together, that becomes a target group. And those are some key questions. So let me ask some questions. There's a fair number of questions that I saw that are there. I'd love to ask them. And thank you so much to Cyber Mommy. I have a beautiful cat. Her name is Cindy. But let me tell you, I'm slightly allergic to her. What is the best monitoring resource in AWS to monitor the health of your resources? Well, with AWS, your monitoring resource is generally CloudWatch, but be fair, and I'm not a sysops person, but there are, and for the maintenance people or the sysops people, there are many wonderful tools that they use to monitor all their systems in and out of AWS that are far better than CloudWatch. There are actually good network monitoring tools. There's a whole career where people focus on SNMP or network management tools and other things. It's actually called network management and sysops. So that is not my career because I'm an architect, and architects don't do maintenance, but there are very good monitoring tools that the maintenance people use called the sysops people. But it's not my world because I don't maintain systems, I design systems, I'm an architect. So I can't tell you how other people do their jobs. So there's a network load balancer, which is what we always use, and AWS came up with something called the gateway load balancer to replace the network load balancer. And really, the gateway load balancer is designed to load balance between firewalls or routers. But you know what? We've all been using a network load balancer for it, and it works perfectly. So Naga, I don't use gateway load balancers because I use network load balancers. Why? Because I can use a network load balancer on AWS and a network load balancer on Azure, and I use the same thing. Plus, AWS provides no performance information on the gateway load balancer whatsoever. So in order to use it, I have to hope it's going to do a good job. And unless I know performance, scalability things, which AWS has not published yet on the gateway load balancer, I'm not in a position to design an architecture. So I don't use the gateway load balancer. It serves the same function as the network load balancer, which I'm very familiar with. My customers are very familiar with, and my customers want to use. So there is a gateway load balancer, but I didn't cover it because it's the load balance between virtual appliances, which is what a network load balancer does. So Chris, you can bring in the next one. There are lots of different traffic control programs supported by load balancers, and every company's load balancer is different. So some do round robin, some do weighted round robin, some have a couple of algorithms. And you know how you're going to find that out? You're going to go to the manufacturer's documentation. So here's the thing. A lot of times the AWS load balancers aren't good enough. And you're going to go to the marketplace and get something from F5 when you need different algorithms. So you got to check that every time because every load balancer is different. Load balancers that are physical from F5 are different than other virtual load balancers, and there are lots of load balancers there. Danica, Route 53 is DNS. So either use AWS's DNS, use your own DNS, use Azure's DNS, use Cloudflare's DNS, buy your own F5 DNS server, which is what I would do. So Route 53 is just the AWS branded DNS server. That's all it is. The routing policy for DNS is configured on the DNS policy. The routing policy for a load balancer is configured on the DNS, or is configured on the load balancer. Two sets of different routing. And the routing on routers is configured on the routers. Good question. Quite simply, set a DNS routing policy that says 50% goes to AWS and 50% goes to Azure. And it's done. That's weighted DNS routing. And no, you don't have to use Route 53. You can use any other ones. Well, the network's global in scope, and there's lots of resources that are global in scope. Lots and lots of them. Okay, so you can go to the next one. AJ, I'm not sure because I've never used a classic load balancer because AWS has been advising against it for years. So I don't know. Having said that, most load balancers have target groups for most vendors. Typically, we listen on one thing per load balancer. So we might have a load balancer for iPhone users that are going to listen to this stuff. We're going to have another load balancer for Google phone users. We'll have another load balancer for Mac users. We'll have another load balancer for Linux users, another load balancer for Windows users. So we're going to have lots of load balancers. And the Lightning Strikers, sometimes we need to stack our load balancers. So if we need the performance of a network load balancer and the intelligence of an application load balancer, it's very frequent for us to do this. I'll show you. This is a very common architecture. You won't see it in certification training, but it's the reality of what we do all the time. Quite frankly, we have two things that we do constantly in cloud architecture. Let's say we need a real load balancer with features and functionalities, and AWS doesn't give us that. We use an elastic load balancer. So let's say we use a network load balancer. Let's say we wanted a bunch of AWS application load balancers. We'd almost do this. We can do an ALB. And bear with me, I'll show you what we do in a lot of cases. So sometimes we need the intelligence of an application load balancer, and we need the speed and performance of a network load balancer. So sometimes we do this. What we do is a network load balancer to an application load balancer, and then each application load balancer will then load balance multiple servers. So this is load balancer stacking, which is pretty common. And if we need high intelligence with high performance, you'll see this constantly in cloud architectures. We do this constantly. Now, you might also find out that you need fancy algorithms for your routing. And there's no cloud-based load balancer that's got the performance you need. And that's going to happen all the time, too. Because AWS stuff that they make, remember, they've not been in this business forever. F5 has spent 20 years perfecting load balancers. AWS does everything in the load balancers, one of 1,000,001 things that they do. So they're not going to be as good, the AWS ones, as the F5 ones. So people also do this. They will get marketplace load balancers that are really good, and they will use a network load balancer to load balance between them. And here's why. If this load balancer sits on a virtual machine, is a virtual machine high performance? No. So we might use a load balancer to load balance across other load balancers as well. So that's the kind of load balancer architectures we deal with in the real world as an architect versus the kind of things that are covered in certification exams. I wouldn't consider a load balancer a security tool, but we might use a load balancer to load balance between two virtual firewalls, which are security tools. So a load balancer will take a big role, Sean, in end-to-end enterprise-wide security. Explain sticky sessions again. So sure. And then, Chris, we have to address the training versus education question. I know that's on your list of things.
Well, do you want to do those now, or do you want to do those after you answer the questions about the content?
Let me answer this, but I want to make sure we cover the difference between training and education versus being properly trained versus having to start at the bottom and torture your career for years. Because, there's a lot of misconception about that, and I don't want anybody getting hurt by making the wrong mistakes. So sticky sessions are quite this. Traffic comes into the load balancer, and let's say it's coming into the load balancer, right? Traffic comes in and gets sent to server 1. Now, the next traffic between Noni the Cat and the Cindy the Cat website goes to the same web server. That's a sticky session. Now, after Cindy the Cat goes to the Noni the Cat website, then my wife goes to the Noni the Cat website, and she's a different user, so she gets sent to a different server the whole time. Now, I want to see Noni the Cat because Abigail took some pretty pictures of her cat, and I know what Abigail's cat looks like, and she's awesome. So I want to go, and I get sent to a new server, and I stay on that server until the end of my connection. That's a sticky session. Great question there, Cecil. Why not? Well, I got to tell you, there's been thousands of people that have used this to pass the exam. So if you don't feel this will prepare you for the exam, do something else to prepare you for the exam. But I'll tell you what, our people get hired every single day of the week off of this. And our people pass the exam every single day on the week on this. So, here's my suggestion. Do our materials. And we're not a certification company. I'm going to tell you that right now. Our goal is not certification. There are plenty of companies that get you certified, and after the people are done their certification, they can sit there and they're unemployed for years. We are not a certification company. I'm going to tell you that right now. We are a get hired people company. Right now, Delroy Bat just texted me. He's been promoted 3 times this year, and all kinds of great things are coming back to him. Yesterday, one of my people that was he was working in security and as a minister. And by security, I mean bodyguarding, just got hired as a cloud architect. So our work is on prepping you for the career. But we also recommend Andrew Brown's completely free AWS Certified Solution Architect Associate course. We recommend it, always do, to go along with ours. And we always recommend a practice exam. But our goal is getting you hired, not worried about a certification exam, but thousands and thousands and thousands of people have used this material to pass their exam. So it's up to you what you choose and how you prepare. Chris, you can go to the next one. Well, why not? So far this year, we've gotten about 100 people cloud architect jobs, and about 50 have never worked in technology before. So here's the difference between training and education. If you take a certification class and all you do is configure things, guess what? You're not employable for anything except for maybe an intro job. Now, let's take the opposite, training and education that prepares you for a career. That's what we provide. So here's the thing. People get doctors. When people become doctors, it's their first job. People get lawyer jobs as their first job. They don't have to work out in the mail room and do all these silly things to get experience. They're properly trained. So, I don't subscribe to the philosophy that here you're going to get certified and then you're going to take a bottom barrel job for 10 years. You're going to do this job and this job and this job. And by the time you're 40, you might have a decent architect job. My first job after leaving practicing medicine was a senior network engineer, and I was the lead architect within 6 months. This year, I've gotten more people their first cloud architect job, whether it was someone that was serving food at a restaurant that got hired by AWS, someone that was doing geospatial surveying that got hired as a cloud architect, a minister that got hired by an architect, and one of my students that hasn't worked in 10 years because of a baby, she just got hired as a cloud architect. So for me, I train people for the career, but that's why we spend 500 hours in our training program versus 10 hours in the certification. So people actually get jobs by getting school and going to education. They don't have to waste their time starting out the bottom. And that's the whole point of education. The education is so you don't make the same mistakes that other people do. And that's why certification for us is just a little piece. The AWS Certified Solution Architect Professional, we say, is less than 10% of what's necessary to get hired. And I got to tell you, in our 500 hours of training, the AWS Certified Solution Architect Professional and the Azure Expert components are less than 20 hours of our time. The other 480 hours are on how to be an architect, design an architect. So people get their first job as a doctor by getting properly trained. People get their first job as a lawyer getting properly trained. I never took any entry-level jobs, and none of my students have ever had to take any entry-level jobs in the last 20 years. But that's the difference between professional development, career development, and certification. Certification is the name of the service and how to configure that service. Beautiful if you want to be a cloud admin. It won't get you a job as a cloud engineer where you need strong engineering skills. And it sure won't get you a job as an architect where you need leadership skills, scale skills, design skills, network and data center skills. So that's what we do. And we're highly successful. Every day, somebody's gotten hired or promoted or both. Chris, you can go to the next one. Do you use load balancers to cache servers? No, we use caches and news for caching. There's servers we use for web caches. Yeah, the AS Health Dashboard is a great status check. Absolutely. You got to figure where is your cache and which cache you're dealing with. So if your cache is related to the database, like a Redis cache for a database, it's not going to have any impact whatsoever because the thing is going to the web server. Now, if you're dealing with the cache itself, you really want it to hit the cache and not necessarily an individual server. So, it kind of more depend on the actual application, what you're trying to do. You probably don't need to use a sticky session with a cache that you would point it to the cache and the cache would go there. But if you're dealing with a network load balancer, there's no way to deal with it otherwise. Teddy, between the Cloud Architect Career Development Program, Tech Accelerator Program, and Tech Interview Master Program, do either one of these contain? Okay, so they're all separate programs, and let me tell you what they are. If someone's looking to get their first cloud architect job, they want the Cloud Architect Career Development Program. It's a one-stop shop to going from wherever they're at to being hired as a cloud architect. Now, the Tech Career Accelerator Program is something I'm very proud of. If you're a cloud engineer and you want to become a VP of engineering, if you're a cloud architect and you want to become a distinguished architect or a principal architect, if you've been an engineer and you want to become a manager or an architect or a leader or any of the bigger leadership roles, program management roles, product architect roles, that's the Tech Career Accelerator Program. So Cloud Architect Career Development Program, get your first cloud architect job. Tech Career Accelerator Program is a leadership program, and it's designed to take you regardless of your tech career and get you promoted and paid far more than you're earning before by giving the leadership skills, the executive communication skills, the soft skills. And the data on this is fantastic. And people do this, they do fantastic. Now, the Tech Interview Mastery Program is an interview program. And if you know everything but need to learn, help out an interview, that's what that's for. So the career development program includes a lot of the leadership content, but not all of it, and a lot of interview training because it's a one-stop shop. So Cloud Architect Career Development Program, get you your first Cloud Architect job, get you cloud hired. Tech Career Accelerator, get you promoted, cloud promoted. But for any tech job, including sales, business, engineering, all of it. We've worked it all. And the Tech Interview Mastery Program is so you can really master the interview. Hope I've answered your questions with that. I wanted to make sure we answered every one of them. So we are about 3/5 through the content. So today is Thursday. Hopefully we can finish it up tomorrow, but if we can't, we'll go Saturday. I'm not sure, but I want to make sure that you're all there. Regarding the question, which is the closest similarity, AWS, Google, Azure, they're all identical. Identical in every way. Only the names have changed. It's like the song. Only the names have changed. Yesterday was saying we're wasting away. I don't remember. But anyway, I won't go down the path because, when I mentioned that. Which Go Cloud course would you recommend for anyone with no experience looking to change careers? The Cloud Architect Career Development Program. That is how you transition careers. Okay, well, if there's any other questions, let me know. And otherwise, I will see you all tomorrow. At 8 a.m., we have a really, really, really fun and exciting premiere with me and a real security guru. And we got deep and dirty. We talked about multi-cloud. We talked about the dangerous bastion hose. We talked about architectural principles, blockchain, and all kinds of cool stuff. So please, please, please join us. I'll be there. It'll be at 8 a.m. And there's some more questions that are popping in, Chris, we probably should answer. And what does the live class entail? The live classes, there's 3 live classes per week. You come to the live class and I train you in how to design an architecture. 2 classes per week, we do architectural training and architectural designs together. 1 class per week, we do leadership. And in between classes, you will have projects and assignments to do, things to improve your interview, things to improve your technical competency, career development plans, things to teach you how to negotiate, things to teach you how to sell, and things to teach you how to get hired. All of it is in there. And you'll do that in between classes. And in between classes, you know what you're going to do? Turn in your homework assignments, and our team's going to give you feedback and make you better. And then, after that, we're going to have lots of fun. We're going to give you some labs, and we're not going to give you silly labs. I mean, sure, we have AWS and Azure labs, so you can say you've done them, but nobody gets hired by doing AWS labs. But we will have you build a cloud from scratch, and we'll teach you how to do it. Work with server virtualization, containers, firewalls, VPN concentrators. We'll have you build Active Directory servers, and you will be building clouds. So when everybody else says, I'm certified, I can set up an EC2 instance, you'll say, I built a cloud. And that's one of the many ways that our students get hired, is because we show competency beyond extreme anything else that's out there. And thank you so much, Yoon Mag. He is cloud hired, by the way, and he's always grateful for our team experts in building a community. And he was one of my amazing students, along with so many of them that were here right today. So that's what the live classes. You'll come, it'll be on Zoom. We'll talk, we'll have a great discussion. Chow is in my live class, so she can give you some extra. Jim Weaver is in the live class. Let's see who else is in the live class. Chow is in the live class. She can give you some perspective. I don't know. Leo was in the live class before I had to hire him because he was so great. Brian McCool is in the live class. Do you have to read all the books you recommend, and are they all part of their program? Everything that you need is inside of the program, and we would like you to do every assignment that's in the program. Here's the thing, and most people don't realize this. Cloud architects are paid as much as physicians or attorneys. And, most of these careers require a $250,000 education and about 7 years of school. So we've been successfully getting people into these jobs every single day, but it's a substantial amount to learn. Now, I promise you, if you work hard, you will earn it and you'll be successful, but you got to do the work. So everything we recommend is inside of our program, and it's part of our content. And you'll be good to go if you do our work, do our labs, do our projects, follow our resume things, follow our interview tips, and show up for classes. You will be rock solid. But I say this because, I can generate a 500-hour training program. And if you don't do the work, thank you so much. Okay, so it just says you love our class. We had another one that's in the class that says she loves it. Nina says she loves it. So I appreciate that. Some of my students sharing their experiences. And, Chris will pop a link of just some of our recent people that have gotten hired. Lots of them never had any background in tech whatsoever. And they're all doing great. So it's been a wonderful day here. If there's not any more questions, at 8 a.m. Eastern tomorrow, we will have this really, really fun, we'll do this video together. We'll watch it. It's a big conversation with me and the security guy. You'll love it. And at 9, we will answer any type of career question you have. Want to know how to build your career? Want to know how to get hired? Want to know what to learn? Want to know the insider secrets, what hiring managers care about? Come tomorrow, ask the questions, and we will talk about it. So, and then after that, back at noon, we'll be back here all day dealing with some fun tech stuff. So super nice to work with you. So here we got lots of people are saying they're happy. So I love that. So thank you, all the Blue Wrench people. I really appreciate it. I saw Chow had a Blue Wrench there. I'm super grateful. I saw Abigail had a Blue Wrench. So I'm super grateful. Leo was there helping out, which I really appreciate. Let's see who else was there with a Blue Wrench. I thought I saw some more people, but whatever the case is, I am very, very grateful. So thank you so much for the day. If you can put it in the chat box, another cloud hired, and I will see you all tomorrow. Take care, everyone.